Beneath the warm, crystalline waters of the western Bahamas, just off the coast of a small island called North Bimini, there lies something that has baffled scientists, fascinated explorers, and ignited the imaginations of millions for more than half a century. Resting on the sandy ocean floor at a depth of roughly 18 to 20 feet, an arrangement of massive limestone blocks stretches for nearly half a mile in what appears to be an intentionally laid pathway. The blocks are enormous. Some of them weigh several tons, many of them are remarkably uniform in shape, and they are aligned in a pattern that to the naked eye looks disturbingly like a road, a wall, or perhaps the foundation of something far more significant than anything nature alone could produce. This is the Bimini Road. Some call it the Bimini Wall. Others refer to it simply as the most controversial underwater formation on the planet. Since its discovery in 1968, it has been at the center of one of the most enduring debates in the worlds of archaeology, geology, and alternative history. Is it a natural geological formation, the kind of thing that the ocean floor produces through millennia of erosion, sedimentation, and tectonic shifting? Or is it something else entirely, a man-made structure, the remnant of a lost civilization that existed thousands of years before the earliest known cultures of recorded history? The stakes of that question are higher than most people realize. If the Bimini Road is natural, then it is simply one more curiosity of the Caribbean seabed, interesting to geologists but ultimately unremarkable in the broader story of human civilization. But if it is man-made, then everything we think we know about the timeline of human history, about when advanced civilizations first arose, about where the cradle of organized society truly rests, all of it would need to be rewritten from the ground up. And lurking behind that question is an even bigger one, a question that has haunted human thought for more than 2,000 years. Is the Bimini Road a piece of Atlantis? To understand why that question matters, to understand why thousands of divers, researchers, historians, and dreamers have descended into those turquoise Bahamian waters over the decades, we need to go back to the very beginning. Not to 1968, when the formation was first spotted from the air. Not even to the early 20th century, when a sleeping prophet made a prediction that would link these waters to the most famous lost civilization in human memory. We need to go much further back than that. We need to go back to ancient Greece, to a philosopher named Plato, and to a story he told that the world has never been able to forget. Around 360 years before the Common Era, the Athenian philosopher Plato composed two dialogues that would become among the most debated texts in all of Western thought. The dialogues were called Timaeus and Critias, and within their pages, Plato described a civilization of extraordinary power and sophistication that had existed in the distant past, a civilization that he called Atlantis. According to Plato, the story of Atlantis had been passed down through generations of Egyptian priests before it reached the ears of a Greek statesman named Solon, who had traveled to Egypt around 600 years before the Common Era. The Egyptian priests told Solon that approximately 9,000 years before his visit, there had existed a great island civilization located beyond the Pillars of Hercules, which most scholars identify as the Strait of Gibraltar. This civilization, Atlantis, was described as a naval power of immense reach, possessing advanced technology, magnificent architecture, and a military force that had conquered large portions of the known world. Plato described the capital city of Atlantis in remarkable detail. It was built on a large island, he said, arranged in concentric rings of water and land. The outermost ring was connected to the sea by a great canal. The buildings were constructed of red, white, and black stone quarried from the island itself. The temples were covered in silver and gold. The harbors were filled with ships. The people of Atlantis lived in luxury and abundance, blessed by the god Poseidon, who had created the island as a home for his mortal beloved Plato. But Atlantis, as Plato told it, was ultimately destroyed. The Atlanteans grew arrogant and aggressive. They attempted to conquer the Mediterranean world but were defeated by the ancestors of the Athenians. And then in a single day and night of catastrophic violence, the island of Atlantis sank beneath the waves and disappeared forever. For more than 2 millennia, scholars have debated whether Plato's account was meant to be taken literally or whether it was a philosophical allegory, a cautionary tale about the dangers of hubris and the inevitable fall of corrupt civilizations. Many mainstream academics have argued that Atlantis was purely fictional, a literary device created by Plato to illustrate moral and political points. They point out that no other ancient source independently corroborates the existence of Atlantis, that Plato himself may have invented the entire narrative, and that the story bears the hallmarks of myth rather than history. But others have argued just as passionately that Plato's account contains too much specific detail to be mere fiction, that the philosopher went out of his way to emphasize that the story was true, and that the consistent tradition of a drowned civilization appears in the myths and legends of cultures around the world, from the flood narratives of Mesopotamia to the oral histories of indigenous peoples across multiple continents. The debate has never been settled. And it is within that unsettled space, that gap between certainty and mystery, that the Bimini Road found its place. Long before the limestone blocks were discovered off the coast of North Bimini, the waters of the western Bahamas had already been linked to the legend of Atlantis by one of the most unusual figures in modern history. His name was Edgar Cayce, and he was known to millions as the Sleeping Prophet. Born in 1877 in the rural countryside of Kentucky, Edgar Cayce was by most accounts an ordinary man who possessed an extraordinary ability. From an early age, Cayce demonstrated what he and his followers believed was a gift of clairvoyance. He could enter a trance-like state, a kind of self-induced sleep, and while in that state, he would speak at length on topics ranging from medicine to spirituality to the ancient past. His utterances during these trances were called readings, and over the course of his lifetime, Cayce produced more than 14,000 of them, all of which were carefully transcribed and preserved by his associates. Many of Cayce's readings dealt with health and healing. People would come to him with ailments that conventional medicine had failed to treat, and Cayce, while in trance, would prescribe remedies and treatments that he had no conscious knowledge of. Some of these treatments proved remarkably effective, and Cayce's reputation grew steadily throughout the early decades of the 20th century. But it was his readings about the ancient past that would prove most controversial and most relevant to the story of Bimini Road. In a series of readings given between the 1920s and the 1940s, Cayce described a civilization that he identified as Atlantis. According to Cayce, Atlantis had been a real place, a vast island or continent that had existed in the Atlantic Ocean tens of thousands of years before the dawn of recorded history. He described the Atlanteans as a technologically advanced people who had harnessed forms of energy unknown to the modern world. They had, he said, developed crystal-based power systems, flying machines, and methods of construction that far exceeded anything the ancient world was known to have possessed. But Cayce also described the destruction of Atlantis, and he did so in terms that echoed Plato's account while adding significant new detail. According to Cayce, Atlantis had not been destroyed in a single catastrophe, but had undergone a series of destructions over a period of thousands of years. The first great catastrophe had occurred around 50,000 years before the Common Era. A second destruction had come around 28,000 years before the Common Era. And the final destruction, the one that sank the last remnants of the continent beneath the Atlantic, had occurred around 10,000 years before the Common Era. It was in the context of these readings that Cayce made the prediction that would eventually draw the world's attention to the waters off Bimini. In a reading given in 1940, Cayce stated that evidence of Atlantis would be found near the island of Bimini. He said that portions of the ancient temples of Atlantis could be discovered beneath the waters near the Bahamian Islands, and he predicted that these discoveries would begin to emerge around 1968 or 1969. At the time, the prediction seemed fantastical, even absurd. Bimini was a small, sleepy island in the western Bahamas, known primarily as a fishing destination and a haunt of the novelist Ernest Hemingway. The idea that the ruins of a lost civilization might lie beneath its surrounding waters was not taken seriously by the scientific establishment. Edgar Cayce himself passed away in 1945, more than 2 decades before the date he had specified for the discovery. But then 1968 arrived, and something happened. On September 2, 1968, a zoologist and diver named J. Manson Valentine, who was affiliated with the Museum of Science in Miami, was conducting an aerial survey of the waters near North Bimini when he spotted something unusual on the ocean floor. Looking down through the clear, shallow water, Valentine saw what appeared to be a large, rectangular arrangement of stone blocks lying on the seabed. The formation was massive, stretching hundreds of yards in a roughly J-shaped or hook-shaped pattern. The blocks appeared to be regular in size and shape, and they were arranged in a way that suggested intentional placement. Valentine was stunned. He had been aware of Edgar Cayce's prediction. He had in fact been searching for exactly this kind of anomaly. And now, in the very year that Cayce had predicted, in the very location that Cayce had specified, he had found what appeared to be a man-made structure lying beneath the waves. Valentine organized a series of dives to examine the formation up close, and what he found only deepened the mystery. The formation consisted of roughly rectangular blocks of limestone, many of them measuring 10 to 15 feet in length and several feet in width. The blocks were arranged in parallel rows, creating what looked unmistakably like a paved road or the foundation wall of a large structure. The blocks were fitted closely together, and in some areas they appeared to be stacked or layered, with smaller stones beneath the larger ones, as if the structure had been deliberately engineered. Valentine's discovery was announced to the world, and it created an immediate sensation. Here, exactly as Edgar Cayce had predicted, in the exact location and the exact year he had specified, a massive underwater stone formation had been found that bore all the hallmarks of human construction. To the followers of Cayce and to the growing community of Atlantis researchers, the discovery was nothing less than vindication. The sleeping prophet had been right, Atlantis had been found, and the Bimini Road was its first visible remnant. The mainstream scientific community, however, was far less enthusiastic. From the very beginning, geologists who examined the formation raised serious objections to the claim that it was man-made. They pointed out that formations very similar to the Bimini Road occur naturally along coastlines throughout the world. These formations are known as beach rock, and they are created through a well-understood geological process. Beach rock forms when loose sand and shell fragments on a beach or in shallow coastal waters become cemented together by calcium carbonate, which precipitates from seawater. Over time, the cemented material hardens into solid limestone. As the rock continues to form and harden, it develops natural fracture patterns, lines of weakness along which the rock tends to crack. These fracture patterns are determined by the crystalline structure of the limestone itself, and they tend to produce remarkably regular, rectangular shapes. When beach rock fractures along these natural lines, the result can look strikingly like a man-made pavement. The blocks appear uniform in size. They seem to be arranged in orderly rows. The joints between them look deliberate. And when the formation is submerged by rising sea levels, the overall effect can be remarkably convincing, especially to observers who are not trained in geology. This was the argument put forward by geologists like Eugene Shinn of the United States Geological Survey, who conducted extensive studies of the Bimini Road in the 1970s and 1980s. Shinn took core samples from the blocks of the formation and analyzed them in the laboratory. His findings, he argued, were conclusive. The blocks were composed of beach rock, a type of limestone that forms naturally in tropical coastal environments. The grain structure of the rock showed that the individual blocks had not been quarried and transported to the site, but had formed in place, exactly where they now rested. The fracture patterns that gave the formation its road-like appearance were natural, the product of geological processes rather than human engineering. Shinn also pointed to the orientation of the formation. The Bimini Road runs roughly parallel to the modern shoreline of North Bimini, which is exactly what you would expect of a beach rock formation. Beach rock forms along the intertidal zone of a coast, and when it fractures, the resulting blocks tend to align with the orientation of the shoreline. If the formation had been a man-made road, Shinn argued, there would be no particular reason for it to follow the contour of the coast so precisely. Furthermore, Shinn noted that radiocarbon dating of the shell fragments within the limestone blocks yielded ages ranging from approximately 2,000 to 4,000 years before the present. This was far too young to be consistent with the Atlantis hypothesis, which required the structure to be at least 10,000 years old. If the blocks had formed naturally from beach rock that was only a few thousand years old, then they could not possibly be the remnants of a civilization that had existed in the deep past. For many in the scientific community, Shinn's analysis settled the question. The Bimini Road was natural beach rock, period. It was an interesting geological formation, certainly, and its resemblance to a man-made structure was striking enough to fool casual observers. But there was nothing about it that required an explanation beyond ordinary geological processes. And yet the debate did not end. It did not end because the proponents of the man-made hypothesis raised their own objections to the geological explanation, objections that were not easily dismissed. One of the most persistent critics of the natural formation theory was David Zink, a professor of English at Lamar University in Texas and an experienced diver who organized multiple expeditions to the Bimini Road throughout the 1970s. Zink spent hundreds of hours diving on the formation, meticulously documenting its features and searching for evidence that would support or refute the man-made hypothesis. Zink made several observations that he believed were inconsistent with the beach rock explanation. First, he pointed out that the blocks of the Bimini Road were not all uniform in composition. While many of them were indeed composed of the kind of shell and sand aggregate that is typical of beach rock, others appeared to be made of a denser, more finely grained limestone that did not match the surrounding geological environment. If all the blocks had formed naturally from local beach rock, Zink argued, they should all be composed of the same material. The variation in composition suggested that at least some of the blocks had been brought to the site from elsewhere. Second, Zink noted that in several areas, the blocks of the Bimini Road appeared to rest on top of smaller support stones, creating what looked like a deliberate foundation. Natural beach rock formations do not typically exhibit this kind of layered construction. When beach rock fractures, the resulting blocks lie flat on the seabed or on the underlying substrate. They do not rest on carefully positioned supports. The presence of what appeared to be prop stones beneath the larger blocks was, in Zink's view, strong evidence of human engineering. Third, Zink pointed to the overall geometry of the formation. While the Bimini Road does follow the general contour of the shoreline, it is not perfectly parallel to the coast. It curves in a distinctive J-shape or hook shape that does not correspond to any obvious geological feature. Moreover, the blocks at the northern end of the formation are arranged in a pattern that seems to widen and become more complex, as if the structure had been designed to serve a particular purpose, perhaps as a harbor, a breakwater, or the foundation of a larger edifice. Zink also argued that the radiocarbon dates obtained by Shinn and others were not necessarily relevant to the question of whether the formation was man-made. Radiocarbon dating measures the age of the organic material within the rock, not the age of the rock itself. If the blocks had been constructed from naturally occurring limestone that contained ancient shell fragments, then the radiocarbon dates would reflect the age of the shells, not the age of the construction. In other words, a builder working 10,000 years ago could have used limestone that contained shells that were only 2,000 or 3,000 years old at the time, and the radiocarbon dates would still show the younger age of the shells rather than the true age of the structure. This was a legitimate methodological point, and it highlighted one of the fundamental difficulties of dating underwater stone formations. Unlike wood or bone or charcoal, stone does not lend itself easily to radiocarbon dating. The organic inclusions within the stone may or may not be contemporaneous with the formation or construction of the structure, and interpreting the dates requires careful consideration of the geological context. Zink's arguments did not convince the geological mainstream, but they were enough to keep the debate alive. And as the years passed, other researchers added their own observations and arguments to both sides of the question. In the 1980s and 1990s, a number of additional studies were conducted on the Bimini Road and the surrounding seabed. Some of these studies supported the natural formation hypothesis, while others raised new questions. One significant study was conducted by the geologist Wyman Harrison and his colleagues, who published a detailed analysis of the formation in the journal Nature in 1971. Harrison and his team concluded that the Bimini Road was indeed natural beach rock and that its road-like appearance was the result of normal fracturing processes. They noted that similar formations could be found at other locations in the Bahamas and throughout the Caribbean, and they argued that there was nothing unique about the Bimini Formation that required an extraordinary explanation. But even Harrison acknowledged that the Bimini Road was unusually regular and well-defined compared to most beach rock formations. The blocks were larger, more uniform, and more closely fitted than was typical. This did not, in Harrison's view, prove that the formation was man-made, but it did make it understandable why so many people had been convinced that it was. On the other side of the debate, researchers associated with the Association for Research and Enlightenment, the organization founded by Edgar Cayce's followers, continued to conduct investigations of the Bimini area throughout the 1970s, 80s, and 90s. These researchers reported finding additional stone formations in the waters near Bimini, including what they described as rectangular stone columns, geometric stone arrangements, and possible building foundations. Some of these reports were accompanied by photographs and video footage that appeared to show deliberately shaped stones lying on the seabed. However, many of these additional findings were disputed by mainstream scientists, who argued that the stones in question were either natural formations or modern debris, such as ballast stones from sailing ships, concrete blocks from construction projects, or other man-made objects that had been dumped or lost in the area over the centuries. The waters around Bimini, like much of the Caribbean, are littered with the detritus of human maritime activity, and distinguishing ancient artifacts from modern refuse on the ocean floor is not always straightforward. One of the more intriguing additional findings was a formation known as the Bimini Road's so-called Second Road, a parallel line of stones located several hundred yards to the southwest of the main formation. This second alignment was shorter and less well-defined than the primary road, but its existence raised interesting questions. If the main formation was natural beach rock, then the second road should also be natural, and its parallel orientation would be consistent with the expected fracture patterns of a beach rock formation. But if the two formations were the remains of a man-made structure, their parallel arrangement might indicate the walls or foundations of a large building complex, a harbor, or perhaps a causeway. The debate continued to simmer through the turn of the millennium, with neither side able to deliver a knockout blow. The geological evidence was strong but not absolutely conclusive, and the alternative evidence was suggestive but not definitive. The Bimini Road remained in a kind of interpretive limbo, too regular and well-defined to be easily dismissed as a natural formation, but too poorly documented and too ambiguously dated to be confidently identified as a man-made structure. It was in this context that a new generation of researchers began to take a fresh look at the Bimini Road, armed with new technologies and new methods of analysis. Among the most significant of these new investigations was the work of the British researcher Greg Little and his wife Laura Little, who began conducting systematic investigations of the Bimini area in the early 2000s. The Littles approached the Bimini Road with a combination of open-mindedness and scientific rigor that set their work apart from much of the earlier research. They used side-scan sonar, underwater GPS, and high-resolution digital photography to create the most detailed maps and records of the formation that had ever been produced, and their findings, while not definitively settling the debate, added significant new data to the discussion. One of the Little's most important findings involved the prop stones that David Zink had identified in the 1970s. Using modern diving equipment and camera technology, the Littles were able to document the presence of support stones beneath the large blocks of the Bimini Road more thoroughly than had previously been possible. They found that in multiple locations along the formation, the large surface blocks were indeed resting on smaller stones that appeared to have been deliberately placed to level or support the upper layer. This was a significant observation because it directly contradicted the beach rock hypothesis. Natural beach rock does not typically form in two distinct layers, with smaller stones supporting larger ones. If the formation were simply fractured beach rock, the blocks would be expected to rest directly on the underlying sand or bedrock, not on an intermediate layer of smaller stones. The presence of support stones, if confirmed, would be very difficult to explain through natural processes alone. The Littles also reported finding what they described as tongue and groove joints between some of the blocks, places where the edge of one block appeared to fit into a matching notch in the adjacent block. This kind of interlocking construction is a hallmark of human masonry and would be extremely unusual in a natural formation. However, other researchers who examined the same areas were not convinced that the features described by the Littles were truly tongue and groove joints rather than natural irregularities in the fracture surfaces of the rock. Another important contribution of the Littles' work was their investigation of the geological context of the Bimini Road. They noted that the formation sits on a substrate of hard limestone bedrock that is significantly older than the blocks themselves. This raised the question of why beach rock would have formed in this particular location and not in others along the same stretch of coast. If the formation were simply a natural product of coastal processes, it should be part of a larger system of beach rock deposits along the Bimini shoreline. But the Bimini Road appears to be an isolated formation, not part of a continuous beach rock system. This isolation is unusual and adds to the mystery of the formation's origins. The Littles also explored the deeper waters around the Bimini Road, looking for additional formations that might be connected to the main structure. In the course of these explorations, they reported finding several anomalous stone features on the seabed, including what appeared to be stone circles, rectangular enclosures, and linear arrangements of blocks. Some of these features were located at depths of 30 to 40 feet, significantly deeper than the main Bimini Road formation, which sits at roughly 18 to 20 feet. The presence of these deeper formations, if they are indeed artificial, would have profound implications for the age of the structures. Sea level in the Bahamas has risen significantly since the end of the last ice age, approximately 10 to 12,000 years ago. At that time, sea levels were roughly 300 to 400 feet lower than they are today, and much of the Bahama Bank, the vast shallow limestone platform on which the Bahamas sit, was dry land. As the ice sheets melted and sea levels rose, the low-lying areas of the Bahama Bank were gradually inundated, and any structures that had been built on what was then dry land would have been submerged. If the Bimini Road and the associated formations were built on dry land during the last ice age, then they would need to be at least 8,000 to 10,000 years old, and possibly much older. This would place them in the same time frame as Edgar Cayce's predictions, and would make them contemporaneous with, or even older than, the earliest known monumental structures in the world, such as Göbekli Tepe in southeastern Turkey, which dates to approximately 9,000 to 11,000 years before the present. The comparison with Göbekli Tepe is worth exploring in some detail, because it illustrates how dramatically our understanding of early human capabilities has changed in recent decades. Göbekli Tepe was discovered in the 1960s but was not seriously excavated until the 1990s, when the German archaeologist Klaus Schmidt began a systematic investigation of the site. What Schmidt found astounded the archaeological world. Göbekli Tepe turned out to be a massive complex of stone structures, including T-shaped pillars weighing up to 20 tons, elaborately carved with images of animals and abstract symbols. The structures were built by hunter-gatherers who had not yet developed agriculture, writing, or metal tools, at a time when conventional archaeology held that humans were incapable of such feats. The discovery of Göbekli Tepe shattered the long-held assumption that monumental construction required the social organization and surplus resources of agricultural civilizations. It demonstrated that pre-agricultural societies could and did build large, complex stone structures, and it pushed back the known timeline of monumental architecture by several thousand years. For proponents of the man-made hypothesis for the Bimini Road, Göbekli Tepe serves as a powerful precedent. If hunter-gatherers in southeastern Turkey could build massive stone temples more than 11,000 years ago, then it is at least plausible that a similarly advanced society could have existed in the Caribbean at around the same time and could have built the kind of stone structures that now lie beneath the waters off Bimini. But there is a crucial difference between Göbekli Tepe and the Bimini Road, and it is a difference that the skeptics are quick to point out. Göbekli Tepe is unambiguously man-made. The pillars are elaborately carved, the layout of the structures is clearly intentional. There are no natural geological processes that could produce the features observed at the site. The Bimini Road, by contrast, is ambiguous. Its features can be interpreted as either natural or artificial, depending on the assumptions and methods of the observer. The blocks are not carved, they do not bear inscriptions or decorations. Their arrangement, while suggestive of human construction, is also consistent with natural fracturing processes. This ambiguity is the fundamental challenge of the Bimini Road and the reason the debate has persisted for more than 50 years. In archaeology, the standard of evidence for identifying a structure as man-made is relatively high. The structure must exhibit features that cannot be explained by natural processes alone. It must be associated with other artifacts, such as tools, pottery, or organic remains that indicate human activity. And ideally, it should be datable through reliable methods that place it within the known timeline of human presence in the area. The Bimini Road meets none of these criteria definitively. Its features can be explained, at least in theory, by natural geological processes. No unambiguous artifacts have been found in direct association with the formation. And the dating evidence is ambiguous, with different methods yielding different results that can be interpreted to support either hypothesis. But the absence of definitive evidence is not the same as definitive evidence of absence, and this is where the debate gets interesting. Consider, for a moment, what we would expect to find if the Bimini Road were indeed the remains of a man-made structure that had been submerged beneath the ocean for 8,000 to 10,000 years. First, we would expect the structure to be severely degraded. 10,000 years of submersion in warm, shallow seawater would subject any stone structure to intense biological and chemical erosion. Marine organisms such as coral, algae, sponges, and birtwing worms would colonize the surface of the stones, gradually breaking them down. The constant motion of waves and currents would shift and rearrange the blocks. Sand and sediment would bury portions of the structure. And the chemical action of seawater would dissolve the calcium carbonate of the limestone, rounding sharp edges and obliterating fine details. In short, if a man-made limestone structure had been sitting on the shallow seabed off Bimini for 10,000 years, we would expect it to look very much like what the Bimini Road looks like today. A collection of large, roughly rectangular blocks worn smooth by the sea, arranged in a pattern that is suggestive of human construction but no longer crisp or precise enough to be unmistakable. Any carvings, inscriptions, or fine architectural details that the original structure might have possessed would have been erased long ago by the relentless action of the ocean. This is an important point. because it means that the very evidence that would most clearly identify the Bimini Road as man-made is the evidence that is most likely to have been destroyed by the passage of time and the action of the sea. The absence of carved details, inscriptions, or fine masonry does not prove that the structure is natural. It may simply reflect the inevitable degradation of a stone structure that has spent millennia underwater. Similarly, the absence of associated artifacts is not necessarily significant. Any tools, pottery, or other objects that might have been left at the site by its builders would have been scattered, buried, or destroyed by 10,000 years of ocean processes. The shallow waters off Bimini are subject to strong currents, frequent storms, and intense biological activity, all of which would tend to disperse and destroy any small artifacts on the seabed. The fact that no artifacts have been found does not mean that none ever existed. It may simply mean that the ocean has done its work. These considerations do not prove that the Bimini Road is man-made. But they do illustrate the difficulty of making definitive judgments about submerged stone formations based on the available evidence. The ocean is an incredibly destructive environment for archaeological remains, and the standards of evidence that apply to terrestrial archaeology may not be entirely appropriate for underwater sites that have been submerged for thousands of years. This brings us to a broader question that is central to the Bimini Road debate and to the broader controversy over lost civilizations. How much of the human past has been lost to rising seas? The end of the last ice age, which occurred between roughly 12,000 and 8,000 years before the present, was one of the most dramatic environmental transformations in the history of the planet. As the vast continental ice sheets that had covered much of the northern hemisphere began to melt, sea levels rose by more than 300 feet. This rise was not gradual and uniform. It occurred in fits and starts, with periods of rapid rise separated by periods of relative stability, but the cumulative effect was enormous. Vast areas of coastal land that had been dry and habitable during the Ice Age were inundated by the rising seas, and any evidence of human habitation on those lands was submerged. The scale of this inundation is difficult to grasp. The Bahama Bank, the shallow limestone platform on which the Bahamas sit, is a prime example. Today, much of the Bahama Bank is covered by shallow water, rarely more than 30 or 40 feet deep. But during the last ice age, when sea levels were hundreds of feet lower, the entire Bahama Bank was above water. It would have been a vast, flat limestone plain extending for hundreds of miles in every direction. If any human communities had lived on this plain during the Ice Age, their homes, their roads, their temples, and their harbors would now be beneath the sea. And it is not just the Bahamas. Coastlines around the world have been dramatically altered by post-glacial sea level rise. The Persian Gulf, which is now a body of water roughly 600 miles long and 200 miles wide, was entirely dry land during the Ice Age. The Sunda Shelf, the shallow continental shelf that connects the islands of Southeast Asia, was a vast low-lying plain that would have been one of the most habitable regions on Earth. The North Sea between Britain and continental Europe was a fertile lowland known to archaeologists as Doggerland, home to thriving communities of Mesolithic hunter-gatherers until it was swallowed by the rising sea around 8,000 years ago. In all of these regions, the rising seas have erased the evidence of whatever human communities may have existed along the Ice Age coastlines. And since coastal environments have always been among the most attractive locations for human settlement, offering access to marine resources, transportation routes, and temperate climates, it is virtually certain that significant evidence of early human civilization has been lost to the sea. This is not a speculative claim. It is a widely accepted fact among archaeologists and geologists. The coastal zones of the Ice Age world were home to human populations, and the evidence of those populations is now underwater. The only question is how advanced those populations were and what kind of evidence they might have left behind. For most mainstream archaeologists, the populations that lived along the Ice Age coastlines were relatively simple communities of hunter-gatherers and fishers, similar to the Mesolithic peoples of Doggerland or the early coastal cultures of Southeast Asia. These communities were sophisticated in their own way, with complex social structures, rich artistic traditions, and deep knowledge of their environments. But they did not build large stone structures, did not develop writing or metallurgy, and did not achieve the kind of centralized political organization that characterizes later civilizations. But for proponents of the lost civilization hypothesis, the picture is very different. They argue that the Ice Age coastal zones may have been home to far more advanced societies than mainstream archaeology recognizes, societies that had developed technologies and organizational capabilities that rival or exceed those of the earliest known historical civilizations. The evidence for these advanced societies, they argue, has been destroyed or submerged by the rising seas, leaving only tantalizing fragments like the Bimini Road to hint at what once existed. This is a bold claim, and it requires extraordinary evidence to support it. But the proponents argue that such evidence exists, not just at Bimini, but at submerged sites around the world. They point to the underwater ruins off the coast of Yonaguni in Japan, a massive stepped stone formation that some researchers believe is a man-made pyramid or temple complex dating to the Ice Age. They point to the submerged stone structures off the coast of Dwarka in India, which Hindu tradition identifies as the legendary city of Lord Krishna, said to have sunk beneath the waves thousands of years ago. They point to the underwater formations near the island of Malta, where what appear to be cart ruts, the parallel grooves left by wheeled vehicles, extend from the shore down into the sea, suggesting that the landscape was once above water and was used by a civilization that has since been submerged. Each of these sites, like the Bimini Road, is the subject of intense debate. Skeptics argue that the Yonaguni Formation is a natural product of the distinctive fracturing patterns of the local sandstone. They argue that the Dwarka structures are the remains of historical period buildings that were undermined by coastal erosion, not the ruins of an ancient legend. They argue that the Malta cart ruts extend into the sea simply because the coastline has eroded since they were carved, not because sea levels were dramatically lower when they were made. But the proponents counter that the sheer number of anomalous underwater formations around the world makes it increasingly difficult to explain all of them as natural phenomena or historical period artifacts. They argue that a pattern is emerging, a pattern of submerged stone structures in coastal areas that were above water during the last ice age, and that this pattern points to the existence of a global maritime civilization that flourished before the Great Melt and was destroyed by the rising seas. This is the context in which the Bimini Road must be understood. It is not just a single anomalous formation on the floor of the Caribbean. It is one piece of a much larger puzzle, a puzzle that encompasses submerged sites around the world and touches on fundamental questions about the origins and antiquity of human civilization. But let us return to the Bimini Road itself and examine the evidence in greater detail. One of the most important aspects of the Bimini Road that is often overlooked in popular accounts is the sheer scale of the formation. The main body of the road stretches for approximately half a mile, or roughly 800 meters. The blocks that make up the formation range in size from small, roughly cubical stones a few feet across to enormous rectangular slabs that measure 15 feet or more in length and weigh several tons. The total mass of stone in the formation is enormous, representing thousands of tons of limestone. If the formation is natural beach rock, then the amount of limestone involved is not unusual for a tropical coastal environment. Beach rock formations can extend for considerable distances along a coastline, and individual formations can be quite thick and massive. But if the formation is man-made, then the construction effort involved would have been substantial, requiring the quarrying, transportation, and placement of thousands of tons of stone. This would imply a level of social organization and engineering capability that goes well beyond what is typically attributed to pre-agricultural societies. The shape of the formation is also significant. As noted earlier, the Bimini Road follows a roughly J-shaped or hook-shaped course, with a long straight section running roughly northeast to southwest, and a shorter curved section at the northern end that hooks back toward the southeast. This shape has been interpreted in various ways by different researchers. Those who believe the formation is natural argue that the J shape reflects the contour of an ancient shoreline. Beach rock forms in the intertidal zone, and the shape of a beach rock formation is determined by the shape of the shore on which it formed. If the ancient shoreline of North Bimini had a curve or bend at its northern end, then the resulting beach rock formation would naturally follow that curve, producing the observed J shape. Those who believe the formation is man-made have suggested several alternative explanations for the J shape. Some have argued that the formation is the remains of a harbor or breakwater, with the curved northern section serving to shelter the interior of the harbor from waves and currents. Others have suggested that the formation is the foundation of a large building or temple complex, with the J shape representing the outline of the structure's footprint. Still others have proposed that the formation is a section of a much larger structure that has been partially destroyed or buried, and that the visible J shape represents only a fraction of the original construction. The question of what lies beneath the Bimini Road is also important. Several researchers have attempted to determine what is under the visible blocks by probing or excavating beneath them. The results have been mixed. In some areas, the blocks appear to rest directly on sand or loose sediment. In other areas, they appear to rest on a layer of smaller stones or rubble. And in at least a few locations, researchers have reported finding what appears to be a second layer of blocks beneath the first, suggesting that the formation may be deeper and more complex than it appears from above. If there is indeed a second layer of construction beneath the visible blocks, this would be very difficult to explain through natural processes. Natural beach rock formations are typically single-layer structures. They form at the surface of the seabed in the intertidal zone, and they do not typically develop multiple layers of distinct blocks. A multi-layered structure would be much more consistent with human construction, in which a foundation layer of smaller stones is laid first, followed by a surface layer of larger, more carefully fitted blocks. However, the evidence for a second layer is not conclusive. The underwater environment makes excavation extremely difficult, and the reports of subsurface structures have not been independently verified by multiple research teams. Until more thorough subsurface investigations are conducted, the question of what lies beneath the Bimini Road will remain open. Another aspect of the formation that has attracted attention is the composition of the blocks. As noted earlier, most of the blocks are composed of shell and sand aggregate, the typical composition of beach rock. But some researchers have reported finding blocks that are composed of a denser, more finely grained limestone that does not match the local beach rock. If these reports are accurate, they would suggest that at least some of the blocks were quarried from a different location and transported to the site, which would be strong evidence of human activity. The question of composition is closely linked to the question of provenance. If the blocks of the Bimini Road all formed in place, as the beach rock hypothesis suggests, then they should all be composed of the same local materials. But if some of the blocks were brought to the site from elsewhere, then they might be composed of materials that are not found in the immediate vicinity. Identifying the provenance of the blocks requires detailed petrographic analysis, the study of the mineral and fossil content of the rock under microscopic examination. Such analyses have been conducted by several researchers, but the results have been interpreted differently by different investigators. Eugene Shinn, the geologist who conducted some of the most thorough analyses of the Bimini Road, argued that the petrographic evidence was consistent with the beach rock hypothesis. He found that the mineral and fossil content of the blocks was similar to that of known beach rock formations in the Bahamas, and that there was no evidence of exotic materials that would indicate transportation from a distant source. But other researchers, including David Zink and the Littles, have argued that Shinn's analyses were not comprehensive enough and that he did not examine a sufficiently representative sample of the blocks. They contend that some of the blocks have petrographic characteristics that are not consistent with local beach rock, and that more thorough analysis is needed before the question of composition can be definitively resolved. The dating of the Bimini Road has been another major point of contention. As mentioned earlier, radiocarbon dates obtained from shell fragments within the blocks have yielded ages ranging from approximately 2,000 to 4,000 years before the present. These dates have been cited by skeptics as evidence that the formation is too young to be associated with Atlantis or any other Ice Age civilization. But the interpretation of these dates is not as straightforward as it might seem. Radiocarbon dating of marine shell material is complicated by the marine reservoir effect, a phenomenon in which the radiocarbon content of ocean water differs from that of the atmosphere. Because the ocean is a large reservoir of dissolved carbon, and because the mixing of atmospheric and oceanic carbon is not instantaneous, the radiocarbon content of marine organisms tends to be lower than that of contemporaneous terrestrial organisms. This means that radiocarbon dates obtained from marine shells tend to be older than the true age of the shells, sometimes by several hundred years or more. Correcting for the marine reservoir effect requires knowledge of the local reservoir conditions, which can vary from one region to another and can change over time. In the Bahamas, the reservoir effect is not well characterized, and the corrections applied to radiocarbon dates from this region are subject to significant uncertainty. This means that the radiocarbon dates obtained from the Bimini Road blocks should be treated with caution and may not accurately reflect the true age of the formation. Furthermore, as David Zink and others have pointed out, the radiocarbon dates reflect the age of the shell fragments within the rock, not the age of the rock formation itself. If the blocks were constructed from pre-existing limestone that contained older shell material, then the radiocarbon dates would reflect the age of the original limestone, not the age of the construction. This is a fundamental limitation of radiocarbon dating as applied to stone structures, and it means that the dates cannot be used to definitively establish either the age or the origin of the formation. Other dating methods have also been applied to the Bimini Road, with varying results. Uranium-thorium dating, which measures the ratio of uranium to thorium isotopes in calcium carbonate, has been used to date some of the blocks and has yielded ages that are broadly consistent with the radiocarbon results. But uranium-thorium dating is also subject to uncertainties, particularly in marine environments where the uranium content of the water can affect the results. Optically stimulated luminescence dating, which measures the time since sediment grains were last exposed to sunlight, has been suggested as a potentially useful method for dating the Bimini Road, but to date, no systematic luminescence dating study has been conducted on the formation. Such a study could potentially resolve some of the dating uncertainties, but it would require careful sampling and analysis that has not yet been undertaken. The difficulties of dating the Bimini Road illustrate a broader challenge that confronts all underwater archaeology. The ocean is an extremely challenging environment for preservation and dating. The same processes that make the ocean so destructive to archaeological remains also make it difficult to apply the standard dating methods that are used on terrestrial sites. Until new dating technologies are developed or existing methods are refined to account for the unique challenges of the marine environment, the age of the Bimini Road will remain uncertain. Despite these uncertainties, the debate over the Bimini Road has continued to attract new participants and generate new research. In recent years, several new investigations have been conducted that have added to the body of evidence and introduced new perspectives on the question. One particularly interesting development has been the application of side-scan sonar and multi-beam bathymetry to the waters around Bimini. These technologies use sound waves to create detailed maps of the ocean floor, revealing features that are invisible to divers and that cannot be seen from the surface. Sonar surveys of the Bimini area have revealed a number of previously unknown features on the seabed, including linear ridges, rectangular depressions, and geometric patterns that were not visible from above. Some of these features have been interpreted by proponents of the man-made hypothesis as additional evidence of human construction. They point to the geometric regularity of the patterns and argue that they represent the remains of walls, foundations, or other architectural features that have been buried by sediment or obscured by marine growth. Skeptics, however, argue that the sonar features can be explained by natural geological processes, such as the differential erosion of limestone bedrock or the formation of solution holes and karst features in the underlying substrate. The karst hypothesis is worth examining in some detail because it illustrates how complex the geology of the Bahamas truly is. The entire Bahama Bank is composed of limestone, a sedimentary rock that is highly susceptible to chemical dissolution by water. Over millions of years, rainwater and groundwater have dissolved the limestone of the Bahama Bank, creating an intricate network of caves, sinkholes, and underground channels known as karst topography. When these karst features are submerged by rising sea levels, they can create patterns on the seabed that appear geometric and regular, even though they are entirely natural. Solution holes, which are circular or oval depressions formed by the dissolution of limestone, can look like the foundations of buildings. Linear solution channels, where water has dissolved the rock along natural fracture lines, can look like walls or roadways. And blue holes, the deep vertical shafts that are a distinctive feature of Bahamian geology, can look like the remains of quarries or wells. The abundance of karst features in the Bahamas means that any investigation of underwater anomalies must carefully distinguish between natural karst formations and genuinely man-made structures. This is not always easy to do, especially when the formations have been modified by thousands of years of marine erosion and biological colonization. But the difficulty of distinguishing natural from artificial features does not mean that the distinction cannot be made. It simply means that the investigation must be thorough and systematic, employing multiple lines of evidence and multiple methods of analysis. And it is here that the study of the Bimini Road has fallen short. Despite more than 50 years of investigation, no truly comprehensive, systematic, multidisciplinary study of the formation has been conducted. The existing research has been piecemeal and often partisan, with different researchers approaching the site with different assumptions and different agendas. What is needed, according to researchers on both sides of the debate, is a thorough, well-funded investigation that combines the best available technologies and methods. Such an investigation would include high-resolution sonar mapping of the entire formation and surrounding area, detailed petrographic analysis of a large and representative sample of blocks, systematic subsurface probing to determine what lies beneath the visible blocks, comprehensive dating using multiple independent methods, and a careful comparison of the Bimini Formation with known natural beach rock formations and known man-made underwater structures from around the world. Such an investigation would not be cheap or easy. Underwater archaeology is inherently expensive and logistically challenging, and the Bimini Road is located in a relatively remote area with limited infrastructure for scientific research. But the potential payoff of such an investigation would be enormous. If the Bimini Road could be definitively identified as either natural or artificial, it would resolve one of the longest-running debates in the history of underwater archaeology and would have profound implications for our understanding of human history. Of course, the possibility remains that even a comprehensive investigation might not produce a definitive answer. The formation may simply be too degraded, too ambiguous, and too poorly preserved to yield a clear verdict. In that case, the Bimini Road would continue to occupy its current position in the gray zone between certainty and mystery, a formation that is too regular to be easily dismissed and too ambiguous to be confidently identified. But even in that case, the Bimini Road would remain important as a symbol and a catalyst. It symbolizes the vast, unexplored territory of the underwater world and the limitations of our knowledge of the human past. And it catalyzes ongoing research and debate that pushes the boundaries of our understanding and challenges us to think more deeply about the origins and trajectory of human civilization. Let us now turn to another dimension of the Bimini Road story, one that is often neglected in the scientific debate, but that is essential to understanding why the formation has captured the public imagination so powerfully and why the controversy surrounding it shows no signs of abating. The Bimini Road exists at the intersection of science and myth, of empirical investigation and spiritual tradition. It is not simply a geological or archaeological question. It is a question that touches on deep human needs and aspirations, on our desire to know where we came from, on our fascination with the idea of lost worlds and hidden knowledge, and on our persistent sense that the past may hold secrets that we have not yet discovered. The association of the Bimini Road with Edgar Cayce's prophecies is central to this dimension of the story. For Cayce's followers, the discovery of the Bimini Road in 1968 was not just an archaeological event. It was a spiritual event, a confirmation of the reality of Cayce's psychic abilities and of the truth of his vision of human history. The fact that the formation was found in the exact location and the exact year that Cayce had predicted was, for believers, proof that Cayce had access to genuine knowledge of the ancient past, knowledge that came not from scholarly research but from a deeper, spiritual source. This interpretation has been immensely influential, and it has shaped the way many people understand and relate to the Bimini Road. For millions of people around the world, the Bimini Road is not an ambiguous geological formation. It is a confirmed remnant of Atlantis, a tangible link to a lost civilization that possessed wisdom and technology far beyond our own. This belief is held with deep conviction and is resistant to the kind of evidence and argument that might change a scientist's mind. The scientific community, understandably, finds this situation frustrating. Scientists are trained to follow the evidence, to revise their conclusions in light of new data, and to maintain a clear distinction between what is known and what is merely believed. The Cayce connection from the scientific perspective is irrelevant to the question of whether the Bimini Road is man-made. The formation is either natural or artificial, regardless of what any psychic may or may not have predicted. And the fact that Cayce's prediction coincided with the discovery does not constitute evidence for the artificial origin of the formation. It could easily be a coincidence, or it could be the result of a self-fulfilling prophecy, in which people who were looking for Atlantis near Bimini found what they were looking for because they were looking for it. But this scientific dismissal, while logically sound, misses something important about the Bimini Road phenomenon. The Cayce prophecies did not just predict the discovery of the formation, they created the context in which the discovery was made. Without Cayce's readings, it is unlikely that anyone would have been searching for underwater ruins near Bimini in 1968. Manson Valentine was aware of Cayce's prophecies and was actively looking for anomalous formations in the area. The discovery was not accidental. It was the result of a deliberate search that was motivated, at least in part, by spiritual beliefs. This raises an interesting philosophical question. If a discovery is made as a result of a search that was motivated by non-scientific beliefs, does that invalidate the discovery itself? The answer, from a strictly logical perspective, is no. The origin of a hypothesis is irrelevant to its truth or falsity. It does not matter whether the idea that there might be man-made structures near Bimini came from psychic readings, from folklore, from a dream, or from a purely scientific analysis of geological data. What matters is whether the idea is correct, and that can only be determined by examining the evidence. This is a point that is sometimes lost in the heated exchanges between skeptics and believers. Skeptics sometimes dismiss the Bimini Road out of hand because of its association with Cayce and Atlantis, treating the non-scientific origins of the hypothesis as grounds for rejecting the hypothesis itself. This is a logical error, a form of the genetic fallacy, in which the origin of an idea is confused with its validity. The Bimini Road should be evaluated on the basis of the physical evidence, not on the basis of who first suggested looking for it or why. Similarly, believers sometimes treat the discovery of the formation as sufficient evidence for the truth of Cayce's entire cosmology, including his claims about Atlantis, crystal energy, reincarnation, and the spiritual evolution of humanity. This is also a logical error, an overgeneralization from a single data point. Even if the Bimini Road turns out to be man-made, that would not automatically validate everything else that Cayce said. It would simply mean that there is a man-made structure on the seabed near Bimini, and the implications of that finding would need to be worked out carefully through further research. The truth, as is so often the case, probably lies somewhere between the extremes. The Bimini Road is neither a confirmed remnant of Atlantis nor a definitively identified natural formation. It is an ambiguous feature of the seabed that may or may not have been shaped by human hands, and the current state of the evidence does not allow us to make a confident judgment either way. But the ambiguity itself is significant. The fact that, after more than 50 years of investigation, the question remains open is remarkable. It suggests that the formation has features that are genuinely difficult to explain, features that do not fit neatly into either the natural or the artificial category. And it suggests that further investigation, using better methods and better technology, is warranted. The story of the Bimini Road also raises important questions about how we define and recognize the remains of ancient civilizations. Our current understanding of human history is based largely on the archaeological record, the physical traces of human activity that have been preserved in the ground. But the archaeological record is not a complete or unbiased sample of the past. It is shaped by the processes of preservation and destruction, which are themselves influenced by geology, climate, and geography. In general, the archaeological record is biased towards sites that are located on dry land, in stable geological environments, and in regions with favorable conditions for preservation. Sites that are located in unstable environments, such as coastal zones, river floodplains, or tropical forests, are much less likely to be preserved, because the geological and biological processes that operate in these environments tend to destroy or bury archaeological remains. This means that our picture of the past is systematically skewed. We know a great deal about cultures that built in stone in dry, stable environments, such as the ancient Egyptians, the Mesopotamians, and the builders of Göbekli Tepe. We know much less about cultures that lived in coastal zones, tropical forests, or other environments where preservation is poor. And we know virtually nothing about cultures that may have existed on land that is now beneath the sea. The Bimini Road, whatever its true nature, is a reminder of this fundamental limitation. It sits in a location that was above water during the last ice age but has been submerged for thousands of years. If it is man-made, it represents a culture that existed in a coastal or island environment that has since been inundated, a culture whose remains would be almost entirely inaccessible to conventional archaeology. If it is natural, it still serves as a reminder that the seabed may hold secrets that we have not yet discovered, and that the familiar story of human civilization may be incomplete. There is a growing recognition among archaeologists that the underwater world represents a vast, largely unexplored frontier for the study of the human past. The development of new technologies, including remotely operated vehicles, autonomous underwater vehicles, advanced sonar systems, and underwater LiDAR, is making it possible to explore the seabed in ways that were unimaginable just a few decades ago. And as these technologies improve, it is likely that new discoveries will be made that challenge our existing understanding of human history. Some of these discoveries have already begun to emerge. In the Black Sea, marine archaeologists have found remarkably well-preserved shipwrecks dating to the time of the ancient Greeks, their wooden hulls and rigging intact in the oxygen-free deep water. Off the coast of Israel, divers have discovered the submerged remains of Neolithic villages, complete with stone walls, hearths, and storage facilities, dating to roughly 9,000 years ago. In the North Sea, trawler nets have brought up bone tools, antler implements, and even a carved piece of mammoth tusk from the drowned landscape of Doggerland. These discoveries confirm that the seabed contains archaeological remains of immense scientific value, and that the systematic exploration of submerged landscapes is an essential complement to terrestrial archaeology. They also suggest that the most important discoveries may still lie ahead, waiting to be found in the vast, unexplored expanses of the continental shelves and the shallow seas. The Bimini Road may or may not be one of those important discoveries. But its existence and the controversy surrounding it has done more than perhaps any other single site to draw attention to the potential of underwater archaeology and to the possibility that the story of human civilization is longer, more complex, and more surprising than we currently imagine. As we approach the end of this first part of our exploration, let us return to the waters off North Bimini and consider what it is like to actually dive on the Bimini Road. Imagine descending through the warm, clear water of the Caribbean. The visibility is excellent, as it usually is in the Bahamas, and you can see 60 or 70 feet in every direction. The water is a luminous shade of turquoise, lit by the tropical sun that streams down from above. As you descend, the sandy bottom comes into view, dotted with patches of sea grass and occasional coral heads, and then you see it, the road. It appears gradually, emerging from the sand and the sea grass like a memory surfacing from the depths of consciousness. At first, you see just a few blocks, large, rectangular, their surfaces encrusted with algae and small corals. Then more blocks appear and you begin to grasp the scale of the formation. The blocks stretch away in both directions, forming a line that extends beyond the limits of your visibility. They are fitted together with a precision that seems impossible for a natural formation, each block snugly adjacent to its neighbors, the joints between them straight and narrow. You swim along the formation, following its course. The blocks are not perfectly uniform, some are larger than others, and some have shifted slightly from their original positions, but the overall pattern is unmistakable. This looks like a road. It looks like something that was built. It looks like the kind of thing that human beings, working together toward a common purpose, would create. You descend closer and examine the surface of the blocks. They are smooth, worn by thousands of years of ocean currents. The edges are rounded, the corners softened. Whatever details might once have been visible on their surfaces have been erased by time and the sea. You run your hand over the stone. It is warm from the sun, surprisingly warm for something 20 feet underwater. You feel the texture of the limestone, the grit of the sand that has been cemented into rock, the tiny shells of long-dead marine creatures embedded in the matrix. You look down into the cracks between the blocks and see sand, pebbles, and small marine organisms. In a few places, you can see what appear to be smaller stones wedged beneath the larger blocks as if supporting them. Are these natural? Are they placed there by human hands? It is impossible to tell just by looking. The ocean has had its way with this formation for thousands of years, and the evidence of human activity, if it ever existed, has been worn down to the point of ambiguity. You swim on, following the road toward its northern end, where the formation curves back on itself in the distinctive J shape that has puzzled researchers for decades. Here, the blocks seem to become larger and more irregular, and the pattern becomes less clear. Some blocks have been shifted by storms. Others are partially buried in sand. The formation seems to fray at its edges, becoming less distinct as it merges with the surrounding seabed. You surface, blinking in the bright sunlight, and look back down at the water. From above, the formation is still visible as a dark line on the light-colored sandy bottom. It runs straight and true for several hundred yards before curving gently to the northeast. It looks from this vantage point exactly like what it has been called for more than 50 years, a road leading somewhere, or a road leading from somewhere, a road built by someone for some purpose at some time in the distant past, or perhaps not. Perhaps it is just rock, just limestone, fractured by the forces of nature into shapes that our pattern-seeking minds interpret as meaningful. Perhaps the road leads nowhere because it was never a road at all. Perhaps it is just one more beautiful, enigmatic feature of the vast and mysterious ocean floor. This is the question that has drawn thousands of people to these waters over the decades. This is the question that has inspired hundreds of articles, dozens of books, and countless hours of debate. And this is the question that, despite all the research, all the analysis, and all the argument, remains unanswered. The Bimini Road is one of the most compelling and most frustrating mysteries of the underwater world. It is compelling because the evidence, while ambiguous, is genuinely suggestive. The formation has features that are difficult to explain through natural processes alone, and its location in an area that was above water during the last ice age makes it plausible, if not proven, that it could be the remains of a human-built structure. It is frustrating because the evidence is not clear enough to settle the question definitively, and the investigation has been hampered by limited funding, difficult working conditions, and the persistent polarization of the debate between believers and skeptics. But the mystery endures, and so does the fascination. Every year, divers descend to the Bimini Road, swimming along its length, examining its blocks, photographing its features, and asking themselves the same question that Manson Valentine asked when he first spotted the formation from the air in 1968. What is this? Who built it? And what does it mean? Those questions will be the focus of the second part of our exploration, in which we will delve deeper into the scientific analysis of the Bimini Road, examine the broader evidence for lost civilizations in the Caribbean and beyond, explore the geological history of the Bahamas and the dramatic changes in sea level that have reshaped the region over the past 20,000 years, and consider what the future of underwater archaeology might reveal about the hidden chapters of human history. The Bimini Road has been waiting beneath the waves for a very long time. It has been waiting for us to find it, to study it, to argue about it, and ultimately, perhaps, to understand it. That understanding may come soon, or it may remain elusive for decades to come. But the search for answers is itself a journey worth taking, a journey that leads us not just to the floor of the Caribbean Sea, but to the very limits of what we know about ourselves, our past, and the long, strange, magnificent story of human civilization on this planet. The search for the truth about the Bimini Road is, in many ways, a search for the truth about humanity itself. It forces us to confront uncomfortable questions about the completeness of our historical knowledge, about the reliability of our methods of investigation, and about our willingness to consider possibilities that lie outside the boundaries of conventional thinking. It challenges us to be both rigorous and open-minded, to demand evidence while remaining receptive to surprise, and there have been surprises. The history of archaeology is filled with discoveries that overturned long-held assumptions and forced the rewriting of textbooks. Troy was once considered purely mythological until Heinrich Schliemann dug it up in the hills of western Turkey. The Minoan civilization of Crete was unknown until Arthur Evans excavated the palace of Knossos at the turn of the 20th century. The cave paintings of Lascaux and Altamira were initially dismissed as forgeries because the scientific establishment could not believe that Ice Age humans were capable of such sophisticated art. Each of these discoveries expanded our understanding of the human past and demonstrated that reality is often stranger and more wonderful than our assumptions allow. The question is whether the Bimini Road will prove to be another such discovery, a key that unlocks a hidden chapter of human history, or whether it will be confirmed as a natural formation, interesting but ultimately unremarkable. Either outcome would be valuable. If the Bimini Road is natural, its study will deepen our understanding of the geological processes that shape tropical coastlines and will provide useful data for the ongoing investigation of beach rock formations worldwide. If it is man-made, its study will transform our understanding of human prehistory and will open a new frontier of research into the civilizations that may have existed during the last ice age. Let us also consider the cultural significance of the Bimini Road within the broader context of the Bahamas and the Caribbean. The islands of the Bahamas have a rich and complex history that long predates the arrival of the first European explorers in the late 15th century. The islands were inhabited by the Lucan people, a branch of the Taino civilization that had spread throughout the Caribbean from their ancestral homeland in the Orinoco River basin of South America. The Lucans arrived in the Bahamas around the 7th or 8th century of the Common Era and developed a sophisticated culture adapted to the island environment, with complex social structures, extensive trade networks, and a deep knowledge of the sea. The Lucans left behind a significant archaeological record, including village sites, burial caves, pottery, stone tools, and rock art. But there is no evidence that the Lucans built anything resembling the Bimini Road. Their architecture was based on wood and thatch rather than stone, and their settlements were located on the islands themselves rather than on the ocean floor. If the Bimini Road is man-made, it was built by a culture that predates the Lucans by thousands of years, a culture for which there is no other archaeological evidence in the Bahamas. This is one of the strongest arguments against the man-made hypothesis. If a stone-building civilization had existed in the Bahamas thousands of years before the Lucans, we would expect to find other traces of their presence, such as stone tools, pottery, habitation sites, or middens. The absence of such evidence suggests either that the builders of the Bimini Road, if they existed, left no other trace, or that the evidence has been destroyed by rising seas and the passage of time. The first possibility is difficult to accept because civilizations that build large stone structures typically leave behind a wide range of other artifacts as well. The second possibility is more plausible, given the dramatic changes in sea level that have occurred in the Bahamas over the past 10,000 years. As discussed earlier, much of the Bahama Bank was dry land during the last ice age, and any evidence of human habitation on that land would now be underwater. If the builders of the Bimini Road lived on the Bahama Bank during the ice age, their villages, tools, and other artifacts would be submerged at depths of 20 to 400 feet, depending on the specific location and the timing of the submersion. Searching for such evidence would be an enormous undertaking, requiring extensive underwater surveying and excavation across a vast area of shallow seabed. Such a search has never been conducted in a systematic way, and until it is, the absence of corroborating evidence cannot be taken as definitive proof that the builders did not exist. The Caribbean region as a whole has been the subject of increasing archaeological interest in recent years, as researchers have begun to appreciate the richness and complexity of the region's pre-Columbian cultures. The Taino civilization, which dominated the Greater Antilles at the time of European contact, is now recognized as one of the most sophisticated societies in the pre-Columbian world, with complex political structures, extensive agricultural systems, and elaborate ceremonial traditions. Other Caribbean cultures, such as the Kalinago of the Lesser Antilles and the various mainland civilizations that interacted with the islands through trade and migration, have also been the subject of significant new research. But the deeper history of the Caribbean remains poorly understood. The archaeological record of the region before about 5,000 years before the present is extremely sparse, and the earliest human presence in the Caribbean is still a matter of debate. Some researchers believe that humans first reached the Caribbean islands around 6,000 to 7,000 years ago, migrating by canoe from the South American mainland. Others have argued for an earlier arrival, possibly as far back as 10,000 years ago or more. If humans were present in the Caribbean during the last ice age, they would have encountered a very different landscape from the one that exists today. The low-lying Bahama Bank would have been an extensive limestone plain, rich in resources and easily accessible from the nearby mainland. The channels between the islands would have been narrower and shallower, and the climate would have been somewhat cooler and drier than it is today. It is not difficult to imagine that human communities could have thrived in this environment, fishing in the shallow waters, hunting on the limestone plains, and perhaps building structures of stone. But imagining is not the same as demonstrating. Without concrete evidence, the idea that a stone-building civilization existed in the Bahamas during the last ice age remains speculative. The Bimini Road, with all its ambiguity, is the closest thing to such evidence that has been found, and its interpretation remains contested. One area that deserves more attention in the Bimini Road debate is the broader pattern of submerged stone formations in the Bahamas. The Bimini Road is not the only anomalous stone formation that has been reported in Bahamian waters. Over the years, divers and researchers have reported finding a variety of stone structures on the seabed throughout the Bahamas, including linear arrangements of blocks, circular stone patterns, and rectangular enclosures. Some of these formations have been investigated and found to be natural features, such as beach rock formations, karst features, or modern debris. But others remain unexplained, and their existence raises the possibility that the Bimini Road is part of a larger pattern of anomalous stone formations that may or may not have a common origin. One particularly intriguing report involves a formation known as the Andros platform, a large rectangular stone structure reported to lie in the shallow waters near the island of Andros, the largest island in the Bahamas. The Andros platform was first described by pilots who observed it from the air and noted its remarkably regular, geometric shape. Subsequent diving investigations have confirmed the existence of a large stone platform on the seabed, but the nature and origin of the formation remain unclear. Another interesting report involves a series of stone circles found on the seabed near the Berry Islands, a chain of small islands between Nassau and Bimini. These circles, which were documented by divers in the 1980s, consist of roughly circular arrangements of stones on the sandy seabed. Some researchers have compared them to the stone circles found at megalithic sites in Europe, such as Stonehenge, while others have suggested that they are natural features created by the rotational movement of large objects on the seabed during storms. These additional formations, like the Bimini Road itself, are subject to the same fundamental ambiguity. They could be natural or they could be artificial, and the current state of the evidence does not allow for a definitive determination. But their existence adds to the sense that the waters of the Bahamas may hold more secrets than we currently know, and that the systematic exploration of these waters could yield important discoveries about the region's geological and perhaps archaeological history. The Bimini Road also invites comparison with submerged stone formations found in other parts of the world, and these comparisons can shed light on both the natural and the artificial possibilities. In the Mediterranean, submerged stone structures have been found at numerous locations along the coasts of Greece, Italy, Turkey, and North Africa. Many of these structures are the remains of known historical civilizations, such as the ancient Greeks and Romans, whose coastal cities have been gradually submerged by a combination of sea level rise and tectonic subsidence. The study of these submerged cities has been a major focus of underwater archaeology and has produced a wealth of knowledge about ancient maritime civilizations. But some Mediterranean submerged structures predate the historical period and may be associated with earlier, less well-known cultures. The megalithic temples of Malta, for example, are among the oldest freestanding stone structures in the world, dating to approximately 5,000 to 6,000 years before the present. Some researchers have noted that the underwater terrain off the coast of Malta contains features that resemble the terrestrial temples, raising the possibility that additional temple structures may lie submerged beneath the sea. In Japan, the Yonaguni Formation, mentioned earlier, is a massive stepped stone structure lying at a depth of about 25 meters off the southern tip of Yonaguni Island. The formation, which was discovered by a diver in 1986, consists of flat platforms, straight edges, sharp corners, and what appear to be stairs and corridors carved into the rock. Some researchers, including the Japanese marine geologist Masaki Kimura, have argued that the formation is a man-made monument dating to the last ice age, when the site was above water. Others, including the geologist Robert Schoch, have argued that the formation is a natural product of the fracturing and erosion of the local sandstone, which tends to break along flat plains and right angles. The debate over the Yonaguni Formation closely parallels the debate over the Bimini Road. In both cases, a submerged stone formation exhibits features that are suggestive of human construction, but can also be explained by natural geological processes. In both cases, the formation is located in an area that was above water during the last ice age, making it at least plausible that it could be the remains of a structure built during that period. And in both cases, the available evidence is ambiguous, with different researchers reaching different conclusions based on the same data. The existence of multiple anomalous underwater formations around the world has led some researchers to propose that a global maritime civilization existed during the last ice age, and that the remnants of this civilization can be found on the submerged coastlines of every continent. This idea, which has been popularized by writers such as Graham Hancock, is controversial in the extreme. Mainstream archaeologists regard it as unsupported by the evidence and inconsistent with the known archaeological record. But the proponents argue that the evidence is growing and that the mainstream archaeological community has been too slow to recognize the significance of underwater discoveries. Whatever one's view of the global civilization hypothesis, it is undeniable that the study of submerged landscapes is transforming our understanding of the human past. Every year, new discoveries are made in the waters off coastlines around the world, and each discovery adds to our knowledge of the environments and communities that existed during the last ice age and the subsequent period of sea level rise. The Bimini Road, in this context, is not just a single anomalous formation. It is a window into a world that we are only beginning to explore, a world that lies beneath the waves and that may hold the answers to some of the most fundamental questions about human origins and capabilities. As we prepare to conclude this first part of our investigation, let us take a moment to reflect on what we have learned and what questions remain. We have learned that the Bimini Road is a large formation of limestone blocks lying on the seabed off the coast of North Bimini in the Bahamas at a depth of approximately 18 to 20 feet. The formation stretches for roughly half a mile and consists of roughly rectangular blocks arranged in a J-shaped pattern. The blocks are composed primarily of limestone, and their age has been estimated at approximately 2,000 to 4,000 years based on radiocarbon dating of shell fragments within the rock. We have learned that the formation was discovered in 1968 by J. Manson Valentine, and that its discovery coincided with a prediction made by the psychic Edgar Cayce, who had stated that evidence of Atlantis would be found near Bimini in that year. The coincidence between the prediction and the discovery has given the Bimini Road a powerful association with the Atlantis legend that has persisted to this day. We have learned that the scientific debate over the Bimini Road centers on the question of whether the formation is natural beach rock or a man-made structure. The natural hypothesis is supported by geological analysis showing that the blocks are composed of the same materials as known beach rock formations and that their arrangement is consistent with natural fracturing processes. The man-made hypothesis is supported by observations of unusual features, including apparent support stones beneath the blocks, variations in block composition, and the overall geometry of the formation. We have learned that the dating of the formation is uncertain and that the radiocarbon dates, while suggestive, do not definitively establish the age of the formation. We have also learned that the ocean is an extremely challenging environment for archaeological preservation, and that the absence of carved details, inscriptions, or associated artifacts does not necessarily prove that the formation is natural. And we have learned that the Bimini Road exists within a broader context of submerged stone formations around the world, formations that are forcing researchers to reconsider the timeline and geography of human civilization, and that are opening new frontiers for archaeological exploration. What remains to be determined is the true nature and origin of the Bimini Road. Is it the product of geological processes, a natural feature of the Bahamian seabed that has been invested with meaning by human observers who see patterns where none exist? Or is it something more, a remnant of human activity from a time so remote that it lies beyond the reach of conventional archaeology, a fragment of a lost world that sank beneath the waves at the end of the last ice age? The answer to that question may come from future research, from new technologies, from new methods of analysis, or from new discoveries in the waters around Bimini or at other submerged sites around the world. Or it may remain forever elusive, a mystery that defies our attempts at resolution, and that continues to inspire wonder, curiosity, and debate for generations to come. In the second part of our exploration, we will go deeper. We will examine the most recent scientific investigations of the Bimini Road in detail, exploring the cutting-edge technologies and methods that are being brought to bear on the question. We will investigate the geological history of the Bahamas, tracing the dramatic changes in sea level, climate, and environment that have transformed the region over the past 20,000 years. We will explore the evidence for early human presence in the Caribbean and consider what forms of civilization might have existed in the region during the last ice age. We will examine the broader evidence for lost civilizations around the world, from the temples of Göbekli Tepe to the megaliths of the Pacific Islands, and we will consider the future of underwater archaeology and what it might reveal about the hidden chapters of human history. The Bimini Road waits beneath the waves as it has waited for millennia. Its stones hold their secrets close, worn smooth by time and tide, their surfaces blank as the pages of an unwritten book. Perhaps those pages will one day be filled. Perhaps we will learn to read the story that the stones are telling, a story not of geology alone, but of human ambition, human ingenuity, and human loss. A story of a world that was and that is no more, and that lives on only in the stones beneath the sea, and in the dreams of those who seek to understand the deepest mysteries of the human past. The turquoise waters of the Bahamas shimmer in the sunlight, concealing their secrets beneath a surface of dazzling beauty. Somewhere down there at the boundary between the known and the unknown, between science and myth, between the solid ground of fact and the shifting sands of speculation, the Bimini Road stretches out across the seabed, silent and patient, waiting for the questions that it has always provoked and the answers that it has never quite provided. What lies beneath those stones? What truths are buried under that sand? What stories have the currents carried away, and what stories remain, lodged in the cracks between the blocks, preserved in the very fabric of the limestone itself? These are the questions that have haunted researchers, explorers, and dreamers for more than half a century. These are the questions that will guide us through the second part of our journey into the mystery of the Bimini Road. And these are the questions that ultimately may lead us not just to the truth about a single underwater formation in the Bahamas, but to a profound new understanding of who we are, where we came from, and what we are capable of achieving. The road stretches on, the mystery deepens, and the search continues. The ocean remembers what the land forgets. Beneath the gentle waves of the western Bahamas, half a mile of massive limestone blocks continue their silent vigil on the sandy seabed, arranged in a formation so provocative that it has divided the world of science and inspired a global conversation about what we truly know about the origins of civilization. In the first part of our journey, we explored the discovery of the Bimini Road, the prophecy that preceded it, the fierce debate between those who see it as natural beach rock and those who believe it is the remnant of a lost civilization, and the broader questions it raises about what the rising seas may have swallowed at the end of the last ice age. Now, in this second part, we go deeper. We descend not just beneath the surface of the water, but beneath the surface of the debate itself, examining the latest investigations, the most compelling arguments on both sides, the geological forces that shaped the Bahamas over millennia, and the tantalizing possibility that the human story is far older, far more complex, and far more astonishing than the conventional narrative allows. Let us begin where we left off, on the seabed off North Bimini, among the stones that have refused to give up their secrets. Since the early 2000s, a new wave of investigations has brought fresh eyes and fresh technology to the Bimini Road. Among the most methodical of these efforts has been the ongoing work of researchers who have combined traditional diving and sampling with advanced remote sensing technologies. High-resolution side-scan sonar, multi-beam bathymetry, sub-bottom profiling, and photogrammetric mapping have all been applied to the formation in recent years, producing a level of detail that was simply unattainable in the 1970s and 80s when the first serious scientific studies were conducted. One of the most significant technological advances has been the use of photogrammetry, a technique in which hundreds or thousands of overlapping photographs are taken of an underwater feature and then stitched together by computer software to create a three-dimensional digital model. Photogrammetric models of the Bimini Road have revealed subtleties in the arrangement and geometry of the blocks that are not easily visible to the naked eye during a dive. These models show, for example, that the blocks along the main axis of the formation are not randomly oriented, but tend to be aligned along two dominant axes, one running roughly parallel to the formation itself and the other running perpendicular to it. This dual alignment is consistent with the fracture patterns that would be expected in beach rock, but it is also consistent with the kind of deliberate orientation that would be found in a constructed pavement or foundation. The photogrammetric models have also revealed that the surfaces of the blocks are not uniformly flat, but exhibit subtle undulations and depressions that could be interpreted as either natural weathering features or the eroded remains of deliberate shaping. In several locations, the models show what appear to be shallow grooves or channels running across the surface of the blocks, roughly parallel to one another. These grooves have been interpreted by some researchers as evidence of tooling, the marks left by stone or metal tools used to shape the blocks. Others have argued that the grooves are simply the result of differential erosion along natural bedding planes within the limestone. The question of tooling marks is crucial to the debate because the presence of unambiguous tool marks on the blocks would be virtually impossible to explain through natural processes. A stone that has been quarried and shaped by human hands retains characteristic traces of the quarrying process, including chisel marks, saw cuts, and percussion fractures. These traces can persist for thousands of years, even in marine environments, if the stone is hard enough and the marks are deep enough. Several researchers have claimed to have found tool marks on the blocks of the Bimini Road, but none of these claims have been universally accepted. The difficulty is that the blocks have been subjected to thousands of years of marine erosion, which has smoothed and rounded their surfaces and obliterated any fine details. If tool marks were ever present, they may have been worn away to the point where they are indistinguishable from natural features. And in the absence of clear, unambiguous tool marks, the question of whether the blocks were shaped by human hands remains open. Sub-bottom profiling, another technology that has been applied to the Bimini Road in recent years, uses acoustic pulses to penetrate the seabed and reveal the layers of sediment and rock beneath the surface. Sub-bottom profiles of the Bimini Road have shown that the blocks of the formation rest on a layer of unconsolidated sand and sediment, which in turn overlies a layer of hard limestone bedrock. In some areas, the profiles show what appears to be a distinct gap between the bottom of the blocks and the surface of the underlying bedrock, suggesting that the blocks are not an integral part of the bedrock, but are a separate layer that rests on top of it. This finding is significant because it bears on the question of whether the blocks formed in place or were transported to the site. If the blocks are natural beach rock that formed in the intertidal zone, they should be directly connected to the underlying substrate with no significant gap between them. The presence of a gap suggests either that the blocks formed on a surface layer of sand that has since been partially washed away, creating a void beneath the blocks, or that the blocks were placed on the seabed from above, as would be expected if they were quarried and transported by human builders. The beach rock proponents have argued that the gap can be explained by natural processes. Over thousands of years, wave action and currents can wash away the sand and sediment from beneath a beach rock formation, creating voids and undercuts that give the appearance of deliberate placement. This process, known as undermining, is well documented in natural beach rock formations around the world and does not require a human explanation. But the proponents of the man-made hypothesis counter that the gaps beneath the Bimini Road blocks are unusually uniform and well-defined, more so than would be expected from natural undermining. They also point to the presence of what appear to be deliberately placed support stones within the gaps, stones that are smaller and differently shaped from the main blocks and that seem to have been positioned to level and stabilize the upper layer. The question of support stones has been one of the most hotly contested aspects of the Bimini Road debate. As noted in the first part of our exploration, David Zink and later researchers documented the presence of smaller stones beneath the main blocks in several locations along the formation. These stones have been described as prop stones, shims, or leveling stones, and their presence has been cited as strong evidence of human construction. Critics have offered several alternative explanations for the prop stones. Some have suggested that they are simply fragments of the main blocks that have broken off and fallen into the gaps beneath them. Others have argued that they are natural cobbles or pebbles that have been washed into the gaps by wave action. Still others have proposed that they are pieces of younger beach rock that have formed in the sheltered environment beneath the main blocks, where conditions for cementation are favorable. To resolve this question, detailed petrographic analysis of the prop stones and the main blocks would be needed to determine whether they are composed of the same material. If the prop stones are composed of a different type of limestone or have a different grain structure from the main blocks, this would suggest that they were brought to the site from elsewhere, which would be strong evidence of human activity. If they are composed of the same material as the main blocks, the picture would be more ambiguous, since they could be either natural fragments or deliberately selected pieces of the same local stone. Such analyses have been conducted on a limited scale, but the results have been inconclusive. Some researchers have reported finding differences in composition between the prop stones and the main blocks, while others have found no significant differences. The sample sizes have been small, and the analytical methods have varied from study to study, making it difficult to draw firm conclusions. This is a recurring theme in the study of the Bimini Road. The evidence is suggestive but not definitive, the analyses have been limited in scope, and the interpretation of the results depends heavily on the assumptions and expectations of the researcher. It is a situation that cries out for a comprehensive, well-funded, multidisciplinary investigation, the kind of investigation that has never been conducted on the Bimini Road. Let us now turn to the geological history of the Bahamas, which provides essential context for understanding the Bimini Road and its possible origins. The Bahamas are not ordinary islands. They are the surface expression of one of the largest and most remarkable geological structures on Earth. The Great Bahama Bank, a vast submarine plateau of limestone that extends for more than 400 miles from northwest to southeast and is more than 100 miles wide in places. The bank is composed of layer upon layer of calcium carbonate sediment, deposited over a period of more than 100 million years by the accumulation of the skeletal remains of marine organisms, primarily corals, algae, and foraminifera. The Great Bahama Bank is a flat-topped platform that rises steeply from the deep ocean floor. On its eastern side, the bank drops off into the tongue of the ocean, a deep trench that plunges to more than 6,000 feet. On its western side, it is bounded by the Straits of Florida, which separates the Bahamas from the mainland. The top of the bank is extraordinarily flat and shallow, with water depths rarely exceeding 30 or 40 feet over an area of thousands of square miles. This extreme shallowness is the key to understanding the dramatic changes that the Bahamas have undergone in response to fluctuations in sea level. During the last ice age, when global sea levels were approximately 300 to 400 feet lower than they are today, the entire surface of the Great Bahama Bank was above water. What is now a shallow submarine platform was then a vast, flat limestone plain, baking in the tropical sun, dissected by shallow valleys and dotted with sinkholes and solution features. The landscape of the Ice Age Bahamas would have been unlike anything that exists in the islands today. Without the moderating influence of the surrounding ocean, temperatures would have been more extreme, with hotter days and cooler nights. Rainfall would have been significantly lower, and the vegetation would have been sparse, consisting primarily of scrubland and low-growing plants adapted to the thin, rocky soil. Fresh water would have been scarce, limited to a few springs and shallow pools fed by the island's modest rainfall. Despite these harsh conditions, the Ice Age Bahamas would not have been uninhabitable. The surrounding ocean would have provided abundant marine resources, including fish, shellfish, and sea turtles. The limestone plain would have supported a variety of terrestrial plants and animals, some of which may have included species that are now extinct, and the flat, open terrain would have made it relatively easy to travel across the landscape, whether on foot or by some other means. The question is whether humans were present in the Bahamas during the Ice Age, and if so, what kind of culture they developed. As discussed in the first part of our exploration, the earliest confirmed human presence in the Bahamas dates to approximately the 7th or 8th century of the Common Era, when the Lucan people arrived from the Caribbean mainland. There is currently no confirmed archaeological evidence of human habitation in the Bahamas before this date. But the absence of evidence is not evidence of absence, especially when the potential evidence lies beneath hundreds of square miles of shallow ocean. If humans were present on the Bahama Bank during the Ice Age, any traces of their presence, including stone structures, tools, pottery, and organic remains, would now be submerged beneath the sea. Detecting and investigating such remains would require systematic underwater surveying of the bank, a task of enormous scale and complexity that has never been undertaken. Some researchers have argued that the Bahamas are simply too remote and too resource-poor to have attracted human settlement during the Ice Age. The islands are separated from the nearest mainland by more than 50 miles of open water, and during the Ice Age, when sea levels were lower, the nearest landmass would have been even farther away. Without boats capable of crossing this distance, humans could not have reached the Bahamas, and there is no evidence that Ice Age populations in the Caribbean region possessed the maritime technology needed for such crossings. But this argument has been challenged by recent research that has pushed back the date of human maritime capability to much earlier than previously thought. Archaeological evidence from Southeast Asia suggests that humans were making open ocean crossings of more than 40 miles as early as 65,000 years ago, when they colonized the island continent of Australia. Similar evidence from the Mediterranean indicates that humans were sailing to offshore islands in the Aegean Sea more than 100,000 years ago. If humans were capable of making open ocean crossings of this distance at such early dates, then the crossing to the Bahamas, a distance of 50 to 60 miles across the Straits of Florida, would have been well within the capabilities of maritime peoples who may have inhabited the Caribbean during the last Ice Age. The absence of boats or other direct evidence of maritime technology in the Caribbean during this period does not prove that such technology did not exist. It may simply reflect the poor preservation of perishable materials such as wood, plant fiber, and animal skin in tropical marine environments. The question of human maritime capability during the Ice Age is directly relevant to the Bimini Road debate, because if humans were indeed present in the Bahamas during the Ice Age, they would have had access to virtually unlimited supplies of limestone, the primary building material of the Bimini Road. Limestone is easy to quarry and shape, even with primitive stone tools, and it is an excellent material for construction in tropical environments. The Bahama Bank is composed almost entirely of limestone, and any human community living on the bank during the Ice Age would have had this material available in abundance. It is also worth noting that limestone construction is one of the oldest and most widespread forms of monumental building in human history. Some of the oldest known stone structures in the world, including the megalithic temples of Malta and the enclosures of Göbekli Tepe, are constructed of limestone. The use of limestone as a building material requires no advanced technology. It can be quarried using stone hammers and wedges, shaped using stone chisels, and transported on wooden rollers or sledges. The skills required for limestone construction are well within the capabilities of pre-agricultural societies, as the example of Göbekli Tepe demonstrates. If we accept for the sake of argument that humans were present on the Bahama Bank during the last Ice Age, and that they possessed the basic stone working skills needed to quarry and shape limestone, then the construction of a feature like the Bimini Road becomes at least theoretically possible. The blocks of the Bimini Road, while large and heavy, are not beyond the capacity of a determined community working with simple tools and techniques. The quarrying, transportation, and placement of stones weighing several tons has been accomplished by pre-industrial societies in many parts of the world, from the builders of Stonehenge to the Moai carvers of Easter Island. But theoretical possibility is not the same as empirical proof. The question of whether the Bimini Road was actually built by human hands cannot be answered by theoretical arguments alone. It requires physical evidence, evidence that the blocks were quarried, shaped, transported, and placed by human beings rather than formed in situ by natural geological processes. And this is where the debate continues to circle back to the same fundamental problem. The available evidence is ambiguous. The blocks of the Bimini Road have features that are consistent with both natural and artificial origins, and the current state of the evidence does not allow for a definitive determination. Let us now examine some of the more recent and more detailed analyses that have been conducted on the formation, focusing on the work that has been done in the 21st century. In 2004 and 2005, a research team led by Greg and Laura Little conducted what they described as the most comprehensive investigation of the Bimini Road since its discovery. The team used a combination of diving, underwater photography, GPS mapping, and side-scan sonar to document the formation in unprecedented detail. They also collected rock samples from the blocks and from the surrounding seabed for petrographic and chemical analysis. The Littles' investigation produced several noteworthy findings. First, they confirmed the presence of what they described as a second tier of blocks beneath the main layer of the formation. By probing and excavating at several points along the road, the team found that the visible surface blocks rested on a layer of smaller, more irregularly shaped stones, which in turn rested on the sandy substrate. The Littles argued that this multi-layered construction was inconsistent with natural beach rock formation and was more consistent with the kind of deliberate foundation construction used in ancient masonry. Second, the Littles documented what they described as anchor stones, large cylindrical or barrel-shaped stones with holes or grooves that might have been used to secure ropes or cables. These anchor stones were found in the vicinity of the Bimini Road, but were not part of the main formation. The Littles suggested that the anchor stones might be associated with a harbor or docking facility that was once part of the same complex as the road. However, other researchers have argued that the so-called anchor stones are simply ballast stones or mooring stones from historical period sailing vessels. The waters around Bimini have been heavily trafficked by ships for centuries, and the seabed is littered with objects that have been thrown overboard or lost from vessels over the years. Distinguishing between ancient artifacts and modern maritime debris on the ocean floor is notoriously difficult, and the identification of the anchor stones as ancient remains has not been universally accepted. Third, the Littles reported finding what they described as a rectangular stone enclosure on the seabed approximately 1 mile south of the main Bimini Road formation. This enclosure, which measured roughly 60 by 100 feet, consisted of large stone blocks arranged in a roughly rectangular pattern. The Littles interpreted this feature as the remains of a building or temple that was part of the same complex as the road. This finding, if confirmed, would be extremely significant because it would suggest that the Bimini Road is not an isolated formation but part of a larger architectural complex. The existence of multiple related structures in the same area would be very difficult to explain through natural geological processes and would strongly favor the man-made hypothesis. But once again, the finding has been disputed. Other researchers who have examined the area described by the Littles have not been able to confirm the existence of the rectangular enclosure or have interpreted the features they observed as natural limestone bedrock formations rather than man-made structures. The poor visibility that sometimes occurs in the waters south of Bimini, due to sediment stirred up by currents and storms, makes it difficult to obtain clear images of the seabed in this area, and the lack of clear documentation has hindered independent verification. The Littles also conducted chemical analysis of rock samples from the Bimini Road and compared them with samples of known beach rock from other locations in the Bahamas. Their analysis showed that the Bimini Road samples had a somewhat different chemical composition from the comparison samples, with higher concentrations of certain minerals and lower concentrations of others. The Littles argued that these differences suggested that the Bimini Road blocks were not ordinary beach rock but had been modified or treated in some way, perhaps by heating or chemical processing. This claim was met with skepticism by geologists who pointed out that the chemical composition of beach rock can vary significantly from one location to another, depending on factors such as water temperature, salinity, sediment supply, and biological activity. The differences observed by the Littles could simply reflect natural variation in the local geological environment rather than human modification. The Littles' work, while controversial, had the important effect of keeping the Bimini Road in the spotlight and encouraging further investigation. Their findings, even where disputed, raised legitimate questions that deserved further study and highlighted the need for more rigorous and systematic research on the formation. In the years following the Littles' investigations, several other researchers conducted their own studies of the Bimini Road, using a variety of methods and approaches. Some of these studies focused on specific aspects of the formation, such as the mineralogy of the blocks, the geometry of the fracture patterns, or the distribution of marine organisms on the surface of the stones. Others took a broader approach, examining the Bimini Road in the context of the regional geology and the overall history of the Bahamas. One particularly interesting line of research has focused on the microstructure of the blocks, examining the internal architecture of the limestone at the microscopic level. Thin section petrography, a technique in which a thin slice of rock is mounted on a glass slide and examined under a polarizing microscope, has been used to study the grain size, grain shape, cementation pattern, and fossil content of the Bimini Road blocks in fine detail. These microscopic analyses have generally supported the beach rock hypothesis, showing that the blocks are composed of a mixture of sand grains, shell fragments, and coral debris cemented together by aragonite and high magnesium calcite, the typical cementing agents of tropical beach rock. The grain structure of the blocks is consistent with formation in the intertidal zone, and the types of fossils present are typical of the shallow marine environment of the Bahamas. However, some researchers have noted that the cementation of the Bimini Road blocks appears to be more thorough and more uniform than is typical of natural beach rock. In most beach rock formations, the cementation is patchy and irregular, with some areas well cemented and others loose and crumbly. The blocks of the Bimini Road, by contrast, appear to be uniformly well cemented throughout, with a consistent density and hardness that is unusual for natural beach rock. This observation has been interpreted in different ways by different researchers. Some have suggested that the unusual cementation reflects unusual local conditions, such as a particularly high concentration of dissolved calcium carbonate in the groundwater or a prolonged period of favorable cementation conditions. Others have suggested that the blocks may have been artificially hardened, perhaps by heating them in a fire or by treating them with some kind of chemical agent. The idea that ancient peoples could have artificially hardened limestone may seem far-fetched, but there is evidence from other parts of the world that pre-industrial societies did indeed develop techniques for modifying the properties of stone. In ancient Egypt, for example, there is evidence that some limestone blocks were treated with a natron-based solution that enhanced their hardness and durability. Similar techniques have been documented in other ancient cultures, including the builders of the megalithic temples of Malta and the stone masons of pre-Columbian Central and South regions. Whether such techniques were used at Bimini is, of course, speculative. There is no direct evidence of artificial hardening in the Bimini Road blocks, and the differences in cementation that have been observed could be explained by natural variation. But the possibility remains open and adds another layer of complexity to an already complicated debate. Let us now broaden our perspective and consider the Bimini Road in the context of the wider Caribbean region and the Atlantic world. The Caribbean Sea is one of the most geologically and ecologically complex regions on Earth. It is bordered by the Greater and Lesser Antilles, the coasts of Central and South regions, and the Bahama Bank, and it contains a diverse array of marine environments, from shallow coral reefs to deep oceanic trenches. The geological history of the Caribbean is dominated by the interaction of several tectonic plates, which has produced a dynamic and ever-changing landscape of volcanic islands, uplifted limestone platforms, and deep submarine basins. The Bahamas, located on the northeastern edge of the Caribbean, sit on a stable carbonate platform that has been accumulating sediment for more than 100 million years. Unlike the volcanic islands of the Lesser Antilles, which are geologically young and tectonically active, the Bahamas are geologically ancient and relatively stable. This stability has allowed the accumulation of enormous thicknesses of limestone, which in some areas exceeds 15,000 feet. The stability of the Bahama Bank is important for the Bimini Road debate because it means that the formation has not been significantly affected by tectonic activity since the last ice age. Unlike sites in tectonically active areas, where earthquakes and volcanic eruptions can dramatically alter the landscape, the Bahamas have remained essentially unchanged in terms of their tectonic setting. The only major change has been the rise in sea level that inundated the bank at the end of the Ice Age. This means that the Bimini Road, whatever its origin, has been sitting on the same spot, at the same depth relative to the surrounding bedrock since it was first formed or placed. It has not been lifted up or pushed down by tectonic forces, and it has not been buried by volcanic ash or lava. The only forces that have acted on it are the biological and chemical processes of the marine environment, the growth of coral and algae, the dissolution and ray precipitation of calcium carbonate, the movement of sand and sediment by currents and storms, and the slow, steady erosion of the limestone by seawater. This geological stability has both advantages and disadvantages for the study of the formation. The advantage is that the formation is well preserved relative to sites in more dynamic environments. The blocks are still in roughly their original positions, and the overall geometry of the formation is still recognizable after thousands of years of submersion. The disadvantage is that the slow, steady processes of marine erosion have had a very long time to act on the blocks, smoothing their surfaces, rounding their edges, and obliterating any fine details that might have provided clues to their origin. The geological stability of the Bahamas also means that sea level change is the primary factor controlling which parts of the bank are above water and which are below. During the last ice age, when sea levels were at their lowest, the entire bank was exposed. As the ice sheets melted and sea levels rose, the bank was gradually inundated, starting with the lowest lying areas and progressing to the higher areas. The rate and pattern of this inundation can be reconstructed from the geological record, and this reconstruction provides important constraints on the possible age of the Bimini Road. Studies of sea level change in the Bahamas have shown that the waters around Bimini were at or below the current level of the Bimini Road, approximately 18 to 20 feet below the present sea surface, at various times during the last 10,000 years. The most recent time when sea level was at this depth was approximately 3,000 to 5,000 years ago, during a period of relatively rapid sea level rise that followed the final melting of the major continental ice sheets. This finding is important because it suggests that the Bimini Road was last above water approximately 3,000 to 5,000 years ago, which is broadly consistent with the radiocarbon dates obtained from the blocks. If the formation is natural beach rock, it would have formed in the intertidal zone during this period and would have been submerged as sea levels continued to rise. If it is man-made, it would have been built on what was then dry land or shallow water and would have been submerged as the sea rose to its current level. But this relatively recent date is not the only possibility. Sea level in the Bahamas has fluctuated significantly over the past 20,000 years, and there were earlier periods when the waters around Bimini were at or below the level of the Bimini Road. The most significant of these earlier periods was the end of the last ice age itself, between approximately 12,000 and 8,000 years before the present, when sea levels were rising rapidly from their ice age low. If the Bimini Road was formed or built during this earlier period, it would be significantly older than the radiocarbon dates suggest, and its origin would be much more difficult to explain through conventional archaeological models. A man-made structure dating to 10,000 or 12,000 years before the present would predate the earliest known civilizations by several thousand years and would require a fundamental revision of the timeline of human cultural development. The question of which period the Bimini Road belongs to is closely tied to the question of dating, which, as we have discussed, remains unresolved. The radiocarbon dates suggest a relatively recent origin, consistent with the natural beach rock hypothesis, but these dates are subject to significant uncertainties and may not accurately reflect the true age of the formation. Other dating methods have not been systematically applied, and until they are, the age of the Bimini Road will remain a matter of debate. Now let us consider the broader pattern of evidence for human activity in and around the Bahamas during the period in question. The waters of the Bahamas and the surrounding Caribbean have yielded a number of intriguing underwater finds over the years, beyond the Bimini Road itself. While none of these finds have been conclusively identified as the remains of a lost civilization, some of them are difficult to explain through conventional means and add to the sense that the region may hold surprises. One such find is the so-called Moselle Shoal Formation, a collection of stone pillars and blocks found on the seabed near the island of Andros. The pillars, which are roughly cylindrical and stand several feet tall, were first reported by divers in the 1970s and have been the subject of intermittent investigation since then. Some researchers have argued that the pillars are the remains of a man-made structure, perhaps a temple or a ceremonial complex. Others have suggested that they are natural limestone pillars formed by the differential erosion of the surrounding rock. Another intriguing find is a series of underwater stone walls reported in the waters around the island of Grand Bahama. These walls, which were documented by divers in the 1980s, consist of linear arrangements of large stone blocks that extend for several hundred feet across the seabed. Like the Bimini Road, the walls have been interpreted both as natural beach rock formations and as man-made structures. In addition to these stone formations, the waters of the Bahamas have yielded a number of unusual artifacts over the years. These include stone balls, cylindrical stone objects, and pieces of shaped stone that do not appear to be natural. Some of these objects have been identified as historical period artifacts, such as grinding stones, cannon balls, or ballast stones from sailing ships, but others remain unidentified, and their presence on the seabed raises questions about the history of human activity in the region. It is important to approach these reports with caution. The waters of the Bahamas have been heavily used by humans for centuries, and the seabed is littered with debris from fishing boats, cargo ships, military vessels, and other maritime activities. Distinguishing between ancient artifacts and modern debris is not easy, and many objects that initially appear anomalous turn out to have mundane explanations. But the sheer number of unusual finds in the Bahamas is noteworthy. While no individual find constitutes proof of a lost civilization, the cumulative pattern of anomalous stone formations and unidentified artifacts suggests that the underwater landscape of the Bahamas may be more complex and more interesting than the conventional geological model allows. Beyond the Bahamas, the wider Caribbean region has also produced evidence of early human activity that bears on the Bimini Road debate. In recent years, archaeological research on several Caribbean islands has pushed back the date of human arrival in the region to much earlier than previously thought. On the island of Trinidad, which is located at the southern end of the Caribbean island chain, close to the coast of South Continent, archaeological evidence suggests that humans were present at least 7,000 years ago, and possibly much earlier. Stone tools and other artifacts found at sites on Trinidad indicate that the island's earliest inhabitants were skilled mariners who were capable of navigating the open waters of the Caribbean. On the island of Cuba, the largest island in the Caribbean, archaeological sites have been dated to approximately 6,000 years before the present, and some researchers have argued for an even earlier human presence based on the discovery of crude stone tools at sites that have not been securely dated. The earliest inhabitants of Cuba appear to have been hunter-gatherers who lived along the coast and exploited marine resources. In the Greater Antilles as a whole, the archaeological record suggests a complex history of human migration and cultural development, with multiple waves of settlement from different source areas over a period of several thousand years. The earliest settlers appear to have been simple foragers, but later arrivals brought increasingly sophisticated technologies and social structures, culminating in the Taino civilization that dominated the region at the time of European contact. The relevance of this Caribbean archaeological record to the Bimini Road debate is that it demonstrates that humans were capable of reaching and inhabiting Caribbean islands at a relatively early date, and that maritime technology was well developed in the region long before the rise of the Taino civilization. If humans could reach Trinidad and Cuba 6,000 or 7,000 years ago, then the crossing to the Bahamas, which is comparable in distance, would have been within their capabilities. But there is still a significant gap between the earliest confirmed human presence in the Caribbean, approximately 6,000 or 7,000 years ago, and the date that would be required for the builders of the Bimini Road if the formation is truly a man-made structure from the Ice Age, approximately 10,000 to 12,000 years ago. Bridging that gap would require evidence that has not yet been found, and until such evidence is discovered, the Ice Age human presence in the Bahamas remains hypothetical. Let us now turn to a question that is central to the entire lost civilization debate. What kind of civilization could have built the Bimini Road if it is indeed man-made? This is a question that is often glossed over in popular accounts, which tend to invoke the name of Atlantis without specifying what kind of society Atlantis might have been. The popular image of Atlantis, shaped by Plato's description and by centuries of imaginative elaboration, is of a civilization of extraordinary technological sophistication, with crystal power systems, flying machines, and knowledge that surpasses our own. but this image is almost certainly unrealistic, at least as applied to the Bimini Road. If the Bimini Road is man-made, the society that built it did not need to be a super civilization with advanced technology. It needed to be a society that could quarry limestone, transport large blocks of stone over short distances, and lay them in a deliberate pattern on the ground. These are skills that have been demonstrated by countless pre-industrial societies throughout human history, from the megalithic builders of Western Europe to the temple builders of Malta to the stone masons of Easter Island. The construction of the Bimini Road, if it is a man-made structure, would have required an organized community of workers with a common purpose. They would have needed basic stone working tools such as stone hammers, wedges, and levers. They would have needed some means of transporting the blocks from the quarry to the construction site, whether by rolling them on logs, dragging them on sledges, or floating them on rafts. And they would have needed a plan, an understanding of the purpose of the structure, and the ability to execute that plan over the course of months or years. None of this requires advanced technology. It does not require metal tools, wheeled vehicles, or literacy. It does not require a centralized government, a professional military, or a monetary economy. It requires only the kind of social organization and technical skill that has been demonstrated by pre-agricultural and early agricultural societies around the world. The example of Göbekli Tepe is particularly instructive in this regard. The builders of Göbekli Tepe were hunter-gatherers who had not yet domesticated plants or animals. They had no metal tools, no writing, and no wheels. And yet they built a complex of monumental stone structures that rivals anything produced by the later civilizations of the ancient Near East. If hunter-gatherers could build Göbekli Tepe 11,000 years ago, then a similar community could, in principle, have built the Bimini Road at around the same time. The question, then, is not whether it is possible for an Ice Age society to have built the Bimini Road. It clearly is possible, as the example of Göbekli Tepe demonstrates. The question is whether it actually happened, and that is a question that can only be answered by the physical evidence. Let us now consider the purpose that the Bimini Road might have served if it is indeed a man-made structure. Several possibilities have been suggested over the years. The most obvious interpretation is that the formation is a road or causeway, a paved surface designed to facilitate travel between 2 points. Roads are among the most basic and most universal of human constructions, and the Bimini Road's elongated, linear shape is consistent with this interpretation. But a road implies destinations at both ends, and no corresponding structures have been identified at either end of the Bimini Road. The formation appears to start and stop without connecting to any other visible features on the seabed. This does not necessarily disprove the road hypothesis, since any structures at the endpoints could have been destroyed by marine erosion or buried by sediment. But it does make the interpretation less straightforward. Another possibility is that the formation is a harbor wall or breakwater, a structure designed to shelter a bay or anchorage from waves and currents. The J-shaped curve at the northern end of the formation is consistent with this interpretation, since a curved wall would be an effective design for deflecting incoming waves and creating a sheltered area on the lee side. If the Bimini Road is a harbor wall, it would imply that the builders were a maritime people who relied on boats for transportation and trade, and who needed a protected anchorage for their vessels. A third possibility is that the formation is the foundation or base of a larger structure, such as a temple, a platform, or a defensive wall. In many ancient construction traditions, large stone structures are built on a foundation of carefully laid blocks that distribute the weight of the upper structure and prevent it from sinking into the soft ground. If the Bimini Road is such a foundation, the upper structure would have been destroyed long ago, and only the base would remain. A fourth possibility, and one that is perhaps the most intriguing, is that the formation served a ceremonial or religious function. Many ancient cultures built processional roads, sacred pathways, or ritual causeways that connected important ceremonial sites. The straight, elongated shape of the Bimini Road, combined with its prominent location along the coast, would be consistent with a ceremonial function. If the formation is a ceremonial road, it would imply a sophisticated religious culture with a tradition of monumental construction, similar to the cultures that built the stone avenues of Avebury and Karnak in Europe or the Sakbi roads of the Maya in Central Territories. Each of these interpretations has its strengths and weaknesses, and none of them can be confirmed or refuted based on the current evidence. The purpose of the Bimini Road, like its origin, remains an open question. Let us now consider the broader implications of the Bimini Road for our understanding of human history and the possibility of lost civilizations. The idea that advanced civilizations existed before the dawn of recorded history is one of the most provocative and controversial ideas in modern thought. It challenges the conventional narrative of human progress, which holds that civilization developed gradually over thousands of years, starting with the domestication of plants and animals in the Neolithic period and progressing through a series of increasingly complex social, political, and technological stages to the great civilizations of the ancient world. According to this conventional narrative, the earliest complex societies emerged in Mesopotamia, Egypt, the Indus Valley, and China between approximately 6,000 and 5,000 years ago. Before that, humans lived in small, mobile groups of hunter-gatherers, without permanent settlements, monumental architecture, or centralized political organization. The transition from hunter-gatherer societies to complex civilizations was driven by the development of agriculture, which produced food surpluses that allowed for population growth, specialization of labor, and the accumulation of wealth. This narrative is supported by a vast body of archaeological evidence, and it is the foundation of mainstream historical and archaeological thinking. But it has been challenged in recent decades by discoveries that do not fit neatly into the conventional timeline. Göbekli Tepe, as we have discussed, demonstrates that monumental construction predates agriculture by several thousand years. Other sites, such as the stone structures at Karahan Tepe and Bonkuklu Tarla in southeastern Turkey, confirm that the Göbekli Tepe phenomenon was not an isolated anomaly, but part of a broader pattern of pre-agricultural monumental construction in the region. These discoveries have forced archaeologists to reconsider the relationship between agriculture and civilization. It now appears that the development of complex social structures and monumental architecture did not require agriculture as a prerequisite. Instead, the capacity for large-scale cooperative endeavor may have been an inherent feature of human societies that predates the Neolithic Revolution. If this is the case, then the conventional timeline of civilization may be too conservative. Societies capable of building large stone structures may have existed much earlier and in many more places than the current archaeological record indicates. The evidence for these early societies may have been destroyed by the passage of time, buried by sediment, or submerged by rising seas, leaving only scattered traces that are difficult to detect and even more difficult to interpret. The Bimini Road, if it is man-made, would fit into this revised timeline. It would represent another example of pre-agricultural or early agricultural monumental construction, comparable to Göbekli Tepe, but located in a different region and a different environment. Its submersion by rising sea levels would explain why no other evidence of its builders has been found on the currently dry land of the Bahamas. But even if the Bimini Road is natural, the broader questions it raises about lost civilizations and submerged landscapes remain relevant and important. The fact that vast areas of habitable land were inundated by rising seas at the end of the last ice age is not in dispute. The fact that human populations lived on these now submerged lands is also not in dispute. The only question is how advanced those populations were and what evidence of their presence, if any, survives on the ocean floor. The answer to that question will depend on future exploration and future discoveries. The seabed of the world's continental shelves represents one of the last great frontiers of archaeological research, and the technologies needed to explore it are only now becoming widely available. As these technologies improve and as more resources are devoted to underwater exploration, it is likely that new discoveries will be made that will challenge and refine our understanding of the human past. Some of the most promising areas for future exploration include the shallow waters of the Persian Gulf, where the drowned landscape of the Ice Age may hold evidence of early human settlement in one of the most important regions for the development of civilization. The Sunda Shelf of Southeast Asia, where the submerged plains that once connected the islands of Indonesia to the Asian mainland, may preserve evidence of the maritime peoples who colonized Australia and the Pacific Islands. The continental shelves of the Western Indian Ocean, where the lost coastlines of the Ice Age may hold clues to the early development of maritime trade and navigation. And of course, the shallow waters of the Bahamas, where the Bimini Road continues to pose its unanswered questions. The future of the Bimini Road itself is uncertain. The formation is located in waters that are subject to frequent hurricanes, which can shift the blocks, bury them under sand, or expose previously hidden features. Over time, the ongoing rise in sea level will increase the depth of water over the formation, making it more difficult to access and study. And the growth of marine organisms on the surface of the blocks will continue to obscure their features, making it ever harder to determine their origin. But the interest in the Bimini Road shows no signs of waning. Every year, hundreds of divers visit the formation, drawn by the mystery and the beauty of the site. Researchers continue to study the formation, using ever more sophisticated technologies and methods. And the public fascination with the possibility of a lost civilization beneath the waves remains as strong as ever. Perhaps the most important legacy of the Bimini Road is not the formation itself, but the questions it has raised about the nature of the human past. By challenging us to think critically about the completeness of the archaeological record, the reliability of our dating methods, and the possibility of civilizations that existed before the rise of recorded history, the Bimini Road has stimulated a conversation that extends far beyond the waters of the Bahamas and touches on some of the deepest and most important questions that human beings can ask. Who are we? Where did we come from? How long have we been building, creating, and organizing ourselves into complex societies? And what have we lost to the relentless advance of the sea? These questions do not have easy answers, but the search for answers is itself a noble and important endeavor, one that pushes the boundaries of human knowledge and expands our understanding of our place in the world. Let us take a moment to consider the psychological and cultural dimensions of the Bimini Road phenomenon, because these dimensions are often overlooked in the scientific debate, but are essential to understanding why the formation has captured the public imagination so powerfully. Human beings are pattern-seeking creatures. We are wired by evolution to perceive order and meaning in the world around us, even when that order and meaning may not objectively exist. This tendency, sometimes called apophenia or pareidolia, is responsible for our ability to see faces in clouds, animals in ink blots, and roads in fractured limestone. The Bimini Road taps into this deep-seated human tendency. When we look at the formation, we see a road. We see order, purpose, intention. We see the work of human hands, and this perception is not irrational. It is a natural and understandable response to a formation that genuinely resembles a man-made structure. But our pattern-seeking tendency can also lead us astray. We can see patterns where none exist, and we can attribute meaning to phenomena that are purely random. The challenge of the Bimini Road is to distinguish between genuine patterns and illusory ones, between evidence of human construction and the deceptive regularity of natural geological processes. This challenge is complicated by the emotional and cultural associations that surround the Bimini Road. The formation is not just a geological or archaeological question. It is a cultural icon, a symbol of the enduring human fascination with lost worlds and hidden knowledge. For many people, the Bimini Road represents hope, the hope that the past holds secrets that have not yet been discovered, that the human story is longer and more magnificent than we currently know, and that the lost civilization of Atlantis was real. This emotional investment can bias our perception of the evidence. When we want something to be true, we tend to see evidence that supports it and to dismiss evidence that contradicts it. This tendency, known as confirmation bias, is one of the most powerful and pervasive cognitive biases in human psychology, and it affects scientists and laypeople alike. In the Bimini Road debate, confirmation bias has been evident on both sides. Proponents of the man-made hypothesis have sometimes overstated the significance of ambiguous features, such as the prop stones and the possible tool marks, while downplaying the geological evidence that supports the natural formation hypothesis. Skeptics, conversely, have sometimes dismissed the anomalous features of the formation too hastily, without fully considering the possibility that the formation may have both natural and artificial components. The ideal approach to the Bimini Road would be one that combines rigorous scientific methodology with genuine intellectual openness, an approach that takes the evidence seriously, follows it where it leads, and remains willing to revise its conclusions in light of new data. Such an approach would neither assume that the formation is man-made nor assume that it is natural, but would instead test both hypotheses against the available evidence and seek out new evidence that could distinguish between them. This kind of approach is easier to describe than to implement, especially in a field that is as emotionally charged and as politically fraught as the study of lost civilizations. Researchers who investigate sites like the Bimini Road often find themselves caught between the scylla of mainstream skepticism, which can be dismissive and close-minded, and the Charybdis of alternative enthusiasm, which can be uncritical and credulous. Navigating between these extremes requires a rare combination of scientific rigor, intellectual courage, and emotional balance. But it is precisely this kind of navigation that the Bimini Road demands. The formation is too important and too intriguing to be left to partisans on either side of the debate. It deserves the best science we can bring to bear, conducted by researchers who are committed to the truth, wherever it may lead. Let us now consider some of the broader scientific questions that the Bimini Road connects to, questions that extend far beyond the formation itself and touch on fundamental issues in geology, archaeology, and the study of the Earth's past. One such question is the nature of beach rock itself. Despite decades of study, beach rock remains a somewhat enigmatic geological phenomenon. The basic process of beach rock formation is well understood. Loose sediment is cemented by calcium carbonate in the intertidal zone, but the precise conditions under which beach rock forms and the factors that control the rate and extent of cementation are still the subject of active research. Beach rock forms in tropical and subtropical environments around the world, but its distribution is patchy and unpredictable. Some coastlines have extensive beach rock formations, others in apparently similar environments have none. Some beach rock formations are thick and well cemented, others are thin and crumbly. The factors that control these variations are not fully understood and may include differences in water chemistry, sediment supply, biological activity, and hydrological conditions. The study of the Bimini Road has contributed to our understanding of beach rock by providing a detailed case study of a large and well-preserved formation. Whether the formation is natural or artificial, the data collected from it, including the petrographic analyses, the chemical analyses, the dating studies, and the geological surveys, have added to the body of knowledge about beach rock and have helped to refine our understanding of the processes that produce it. Another question that the Bimini Road connects to is the study of sea level change and its effects on coastal landscapes. The rise in sea level that has occurred since the end of the last ice age is one of the most dramatic environmental changes in the history of the planet, and its effects on coastal environments are still being felt today. The study of submerged landscapes like the Bahama Bank provides important data on the rate, pattern, and consequences of sea level rise. data that is directly relevant to our understanding of current and future sea level change in the context of climate change. The Bimini Road, by virtue of its depth and location, provides a marker of past sea level. The depth at which the formation sits, approximately 18 to 20 feet below the present sea surface, indicates the approximate sea level at the time the formation was at the surface. By combining this information with data from other sea level indicators in the Bahamas, such as coral terraces, submerged speleothems, and mangrove peat deposits, researchers can reconstruct the history of sea level change in the region with considerable precision. This kind of sea level reconstruction is important not only for understanding the past, but also for predicting the future. As global temperatures continue to rise due to the accumulation of greenhouse gases in the atmosphere, sea levels are expected to increase significantly over the coming centuries. Understanding the patterns and rates of past sea level rise can help us anticipate the impacts of future rise and develop strategies for adapting to the changes that lie ahead. The Bimini Road also connects to the study of carbonate geology, the branch of geology that deals with the formation, diagenesis, and erosion of carbonate rocks such as limestone, dolomite, and marble. The Bahamas are one of the world's premier natural laboratories for the study of carbonate geology, and the processes that operate there, including sedimentation, cementation, dissolution, and bioerosion, are studied by geologists from around the world. The blocks of the Bimini Road, whether natural or artificial, are composed of carbonate rock and have been subjected to thousands of years of carbonate geological processes. The study of these processes on the blocks of the formation can shed light on the rates and mechanisms of limestone diagenesis in the marine environment, providing data that is relevant to a wide range of geological and environmental questions. Now, let us return one final time to the central question of this exploration. Is the Bimini Road natural or man-made? After examining the evidence from every angle, after considering the geological, archaeological, historical, and cultural dimensions of the question, what can we conclude? The honest answer is that we cannot conclude anything with certainty. The evidence is ambiguous and the question remains open. The geological evidence supports the natural beach rock hypothesis, but does not definitively exclude the possibility of human construction. The anomalous features of the formation, including the possible support stones, the variation in block composition, and the unusual geometry, are suggestive of human activity but can also be explained through natural processes. The dating evidence is consistent with both a relatively recent natural origin and an older artificial one. And the absence of associated artifacts and corroborating structures, while problematic for the man-made hypothesis, can be explained by the destructive effects of thousands of years of marine erosion. In the absence of definitive evidence, reasonable people can and do disagree about the nature of the Bimini Road. Some look at the evidence and see a natural formation that has been invested with meaning by humans who are predisposed to see order and purpose in the natural world. Others look at the same evidence and see the worn and battered remains of a human construction that has survived thousands of years of submersion in a harsh marine environment. Both interpretations are defensible, and both have implications that extend far beyond the Bimini Road itself. If the formation is natural, it reminds us of the extraordinary power of geological processes to create forms that mimic human construction, and it cautions us against reading too much into ambiguous evidence. If the formation is man-made, it opens a window into a chapter of human history that has been hidden from us for millennia, and it challenges us to reconsider our assumptions about the timeline and geography of human civilization. The truth may lie in a place that neither the hardcore skeptics nor the dedicated believers have fully considered. It is possible, for example, that the Bimini Road is a natural beach rock formation that was subsequently modified by human activity. Ancient peoples may have recognized the road-like appearance of the fractured beach rock and enhanced it by rearranging some of the blocks, adding support stones, or building additional structures on top of or adjacent to the natural formation. This kind of human modification of natural features is well documented in archaeological contexts around the world, from the rock shelters and cave walls of Paleolithic Europe to the natural rock outcrops that were incorporated into the temples and cities of the ancient world. If the Bimini Road is a hybrid formation, partly natural and partly artificial, this would explain many of the puzzling features that have fueled the debate. It would explain why the blocks are composed of local beach rock materials, as the natural formation hypothesis predicts, while also exhibiting features such as support stones and unusual geometry that are more consistent with human construction. It would explain why the radiocarbon dates suggest a relatively recent age for the blocks, while the overall geometry of the formation suggests a more deliberate design. And it would explain why no unambiguous artifacts have been found in association with the formation, since the human modifications may have been relatively minor and may not have involved the use of tools or other objects that would leave an archaeological trace. The hybrid hypothesis has not been thoroughly explored in the literature, but it deserves serious consideration. Many of the world's most important archaeological sites are, in fact, hybrid features, natural landforms that were modified and enhanced by human activity over long periods of time. The recognition that human and natural processes can interact to produce complex features is an important insight that could help to bridge the gap between the two opposing camps in the Bimini Road debate. Whether the Bimini Road is entirely natural, entirely artificial, or something in between, it remains one of the most fascinating and most enigmatic features of the underwater world. It is a place where the boundaries between nature and culture, between geology and archaeology, between science and myth, become blurred and uncertain. And it is a place that continues to draw people, from scientists to spiritual seekers to casual tourists, who are captivated by its beauty, its mystery, and its promise of hidden truths. The Bimini Road is also a testament to the enduring power of the Atlantis legend. For more than 2,000 years, the story of Atlantis has captivated the human imagination, inspiring countless works of literature, art, philosophy, and science. The legend has been interpreted and reinterpreted in every age, reflecting the concerns, aspirations, and anxieties of each successive generation. In Plato's time, Atlantis served as a cautionary tale about the dangers of hubris and the inevitable fall of corrupt civilizations. In the age of exploration, Atlantis was reimagined as a lost paradise, a golden age of wisdom and abundance that had been destroyed by divine punishment. In the modern era, Atlantis has become a symbol of the hidden potential of the human past, a reminder that history may hold surprises that we have not yet imagined. The Bimini Road, by its very existence, keeps the Atlantis legend alive. Whether or not the formation is actually connected to the civilization that Plato described, its association with the legend ensures that the questions raised by the Atlantis story continue to be asked. Where did civilization begin? How far back does the human capacity for organized endeavor extend? What have we lost to the passage of time and the forces of nature? And what might we still discover if we have the courage and the resources to look? These are questions that transcend the boundaries of any single discipline. They are questions for geologists and archaeologists, but they are also questions for historians, philosophers, and poets. They are questions about the nature of knowledge, the limits of evidence, and the relationship between what we know and what we believe. The Bimini Road does not answer these questions, but it asks them with a clarity and urgency that is difficult to ignore. And in asking them, it serves a purpose that may be more important than any specific conclusion about its origin. It reminds us that the world is larger, older, and more mysterious than we sometimes allow ourselves to believe. As we bring this exploration to a close, let us return one final time to the waters off North Bimini. The sun is setting over the Caribbean, painting the sky in shades of gold and crimson. The water is calm, the surface smooth as glass. Beneath that surface, the Bimini Road rests on the sandy seabed, its blocks glowing faintly in the last light of the day. A school of tropical fish swims along the formation, their bright colors flashing in the fading light. A nurse shark glides past, its sleek body casting a shadow on the stones. A sea turtle paddles overhead, its ancient eyes gazing down at the blocks with an expression of patient wisdom. The stones are silent. They have been silent for a very long time, perhaps for thousands of years. They do not speak of their origins. They do not reveal their secrets. They simply exist, massive and enigmatic, a puzzle without a solution, a question without an answer, but they are not without meaning. To those who have dived on them, touched them, photographed them, and studied them, the stones of the Bimini Road are profoundly meaningful. They represent a boundary between the known and the unknown, a threshold that we have not yet crossed but that beckons us forward with an irresistible allure. Perhaps one day, a new technology, a new method, a new discovery will provide the key that unlocks the secret of the Bimini Road. Perhaps a diver will find the artifact that proves, once and for all, that the formation was built by human hands. Or perhaps a geologist will develop a new analytical technique that demonstrates, beyond any reasonable doubt, that the formation is entirely natural. Either way, the search will have been worthwhile. The pursuit of knowledge, even when the knowledge proves elusive, is one of the noblest activities of which human beings are capable. It is the pursuit that has driven us from the caves to the stars, from the darkness of ignorance to the light of understanding. And it is the pursuit that drives us still, down into the warm, clear waters of the Bahamas, down to the stones that wait on the seabed, down to the mystery that will not let us rest. The Bimini Road is more than a collection of limestone blocks on the ocean floor. It is a mirror in which we see our own deepest desires and our own most profound uncertainties reflected back at us. We want to know where we came from. We want to understand our past. We want to believe that the story of humanity is grand and magnificent, that our ancestors were capable of greatness, and that the world holds wonders that we have not yet discovered. The Bimini Road feeds those desires, and it challenges them. It offers tantalizing hints of a lost world, but it withholds the proof that would make that world real. It invites us to imagine, to speculate, to dream, but it also demands that we think critically, test our assumptions, and accept the possibility that the truth may be different from what we hope. This tension between imagination and evidence, between dream and reality, between the desire to believe and the discipline of skepticism, is at the heart of the Bimini Road phenomenon. And it is in many ways at the heart of the human condition itself. We are creatures who dream of Atlantis. We are creatures who imagine golden ages and lost paradises and hidden cities beneath the sea. We are creatures who look at the stars and wonder if we are alone, who look at the past and wonder what has been forgotten, who look at the ocean and wonder what lies beneath. The Bimini Road is a monument to that wondering. Whether it was built by human hands or shaped by natural forces, it stands as a testament to our insatiable curiosity, our relentless quest for understanding, and our enduring faith that the world is more wonderful than we know. The sun has set now over the Bahamas. The sky is dark and the stars are beginning to appear, one by one, in the great vault of the heavens. The water is black and still, the Bimini Road invisible beneath the surface, hidden in the darkness as it has been hidden for millennia, but it is still there. The stones are still there, resting on the seabed, waiting for the dawn when the sun will rise again and the divers will descend once more into the turquoise water, waiting for the next researcher who will bring a new tool, a new method, a new perspective to bear on the ancient mystery. Waiting for the question that has never been asked, the observation that has never been made, the connection that has never been drawn. The Bimini Road waits, and we, drawn by the same curiosity that has always driven our species to explore the unknown, will continue to seek it out, to study it, to argue about it, and to wonder at it. Because the mystery of the Bimini Road is, at its deepest level, the mystery of ourselves. It is the mystery of what we are capable of, what we have forgotten, and what we might yet discover about the long, strange, magnificent journey that brought us from the depths of prehistory to the present moment. The stones beneath the sea hold their counsel. the ocean keeps its secrets, and the search goes on. In the final analysis, the Bimini Road teaches us humility. It teaches us that there are things we do not know, mysteries we cannot yet solve, questions we cannot yet answer. It teaches us that the earth is full of wonders that exceed our understanding, and that the story of our species on this planet is longer, richer, and more complex than any single narrative can capture. It teaches us that the past is not a closed book but an open frontier, a vast territory of unknowns that stretches back beyond the reach of memory, beyond the reach of written records, beyond the reach of the archaeological spade and the geologist's hammer. Somewhere in that vast territory, the truth about the Bimini Road lies waiting to be found. And somewhere in that vast territory, perhaps, lies the truth about other mysteries as well, mysteries that we have not yet begun to suspect, mysteries that will astonish and transform us when they are finally revealed. The ocean has been keeping these secrets for a very long time. It has been patient, far more patient than we are. It has watched civilizations rise and fall on the land above. It has watched empires come and go. It has watched the slow, steady march of human knowledge, from the first crude stone tools to the satellites that orbit above the clouds. And through all of it, the ocean has kept its counsel, holding its secrets close, revealing nothing that it did not choose to reveal. But the ocean is not impenetrable. With each new technology, each new method, each new expedition, we penetrate a little deeper into its mysteries. We see a little more of what lies beneath the surface. We understand a little more of the processes that have shaped the seabed and the landscapes that lie hidden below. And so the story of the Bimini Road is not over. It is, in many ways, just beginning. The questions that were asked in 1968, when Manson Valentine first spotted the formation from the air, are the same questions that are being asked today. But the tools we have to answer them are immeasurably more powerful, and the body of knowledge we can draw on is immeasurably richer. The next chapter of the Bimini Road story will be written by a new generation of researchers, armed with technologies that Valentine and Zink and Shinn could never have imagined. Autonomous underwater vehicles equipped with high-resolution cameras and sonar will survey the formation and its surroundings in unprecedented detail. Advanced chemical and isotopic analyses will probe the composition and history of the blocks with a precision that was impossible just a few years ago. Machine learning algorithms will analyze the data, identifying patterns and anomalies that the human eye might miss. And perhaps somewhere in all that data, the answer will emerge. Perhaps the evidence will finally be clear enough, comprehensive enough, and unambiguous enough to settle the question once and for all. Perhaps we will finally know whether the Bimini Road is the work of nature or the work of human hands, or perhaps the mystery will endure. Perhaps the evidence will remain stubbornly ambiguous, refusing to yield a clear verdict. Perhaps the Bimini Road will continue to occupy its place in the gray zone between the known and the unknown, a permanent enigma, a question that has no answer, a road that leads nowhere and everywhere at once. Either way, the journey will have been worth taking. The exploration of the Bimini Road has enriched our understanding of geology, archaeology, and the history of our planet. It has inspired countless people to think deeply about the nature of the past and the limits of our knowledge. And it has reminded us in the most vivid and compelling way possible that the world beneath the waves is a world of wonder, mystery, and limitless possibility. The Bimini Road stretches across the seabed, half a mile of stone blocks lying in the warm, clear water of the Bahamas. It has been there for a very long time, perhaps for thousands of years. It will be there for a very long time to come, long after we have gone, long after our questions have faded into silence, long after the last diver has surfaced and swum away. The stones will remain, the mystery will remain, and the ocean, vast and patient and incomprehensibly ancient, will continue to hold its secrets as it has always done, as it will always do until the end of time. This is the Bimini Road, an enigma written in limestone, a question posed by the sea. A road that may lead to Atlantis, or may lead only to the limits of human knowledge and imagination, but a road nonetheless. A road that invites us to walk it, to follow it wherever it leads, and to never stop searching for the truth that lies perhaps just beyond the next stone, just beneath the next wave, just around the next bend in the endless, fascinating, unfathomable road of discovery. The waters of the Bahamas are quiet tonight. The stars shine down on the dark surface of the sea. Somewhere beneath those stars, beneath that surface, the Bimini Road waits. And somewhere out there, someone is preparing to dive. Someone is checking their gear, reviewing their data, formulating their hypotheses. Someone is getting ready to descend once more into the turquoise depths, to swim along the ancient stones, to run their hands over the worn surfaces of the blocks, and to ask the question that the Bimini Road has always asked and never answered. What are you? Who made you? And what do you have to tell us about the world that was? The dive will happen, the question will be asked, and perhaps this time the stones will speak. Until then, the road stretches on, silent and patient beneath the waves, a highway to nowhere or a highway to everywhere, a monument to mystery, a testament to the enduring, irresistible, magnificent human compulsion to explore, to discover, and to understand. The Bimini Road, the underwater highway, the road to Atlantis, the road to truth. The road to the unknown, it waits for us still.